In this video, we're going to be building the iconic Dragonslayer. The Dragonslayer has been continuously wielded for the past 35 years by Guts in the manga Berserk. In my opinion, this is the original giant sword to end all giant swords. To date, no one has attempted to build a full-scale version of this sword, so I think it's the perfect challenge for my lunatic self. Alright, that's all the introduction we need for this behemoth. Let's get right into it. Hey, real quick, check this out. Pretty weird, right? If only there was some way to rectify the situation. Oh yeah, and buy my merch. It's pretty sweet, right? Alright, so first things first, we've got our blank for the blade. Now this thing is by far the biggest I have ever made. Maybe even the biggest I ever will make. We've got 517 pounds of steel here. This thing is a solid 2 inches thick. It's about 50 millimeters. I definitely cannot pick that up by hand, so I've got a lifting magnet here, and believe it or not, that can pick up almost a full ton. Very useful for this sort of thing, especially when I need to pick it up and put it down, you know, nicely, gently, so to speak. I have a very hungry cat over here. Anyway, I have a forklift now, but this room is pretty cramped. So not a whole lot of room to drive a forklift around. I'm going to use an engine hoist actually. It's actually right there. I'm going to pick it up with that. I'm going to stick it on this table. Now I've actually fabricated 2 new tables just for this project. This is kind of like a general fabrication table. Probably weighs 500 pounds I would say. And this is my new dedicated welding table. This is made from an old milling machine table. It weighs 4,000 to 4,500 pounds or so. Needless to say, I shouldn't need anything else for this kind of project or any future project. Of course, I've already ran into my first issue, and that is I didn't use tall enough boards here to raise the plate off the ground, and these legs do not fit underneath, so I can't actually position the engine hoist close enough. You can see the hook right there. I need to get it there. So I guess I'm gonna break out the powerlifting belt. Okay, that was just a little bit of work. I'm already exhausted and all I've done is move the plate onto the table. Alright, let's get this thing cleaned up. We'll get it all marked out to the general shape of the sword. And we're going to cut this with an oxyacetylene torch. Well, hopefully anyway. I've never cut anything this thick. I've got a decent torch rig, but that's a lot of cutting. I don't even know if I have enough gas. But doing this with an angle grinder would be not impossible, but extremely problematic. Allow me to demonstrate here. This is a standard 4.5 inch angle grinder with a nearly new disc on it. And the problem is, if I can show you, it can't cut all the way through, not really even close. Once you get to this far, it's going to be hitting this collar, and it's going to be impossible. Now, I could use my biggest angle grinder, which uses these monster cutoff discs. And you can see, you know, this would work, but the only downside is these cutoff discs, the big ones, are quite thick. These are at least twice as thick as the little ones I use. So that's going to be a lot of grinding time and a lot of material usage. And not only that, I have to hold a 15-pound power tool for probably, I don't know, half a day. And I'm just really not built for that. My hands would probably fall off, so torch it is. Alright, here we go. I've got the whole thing marked out. I don't know if you can tell, but yeah, I've scratched in all the dimensions into the surface of the steel so I won't lose them. And then I went on the outside of that mark with the soapstone, and that's where I'm going to actually do the cutting. So the width of this soapstone will give me the buffer I need, you know, in case I kind of tilt the torch a little bit. I'm not making the sword a little bit too small or something like that. and the excess will be machined off. Alright, well, my first cut actually seemed to be pretty successful. I actually started down this end originally, and you can see I kind of screwed up. I kind of a little too far away from that soapstone line, but then I got it back in pretty well. And you can actually see where I wasn't getting full torch penetration, and I had to break off that last piece right here, right at the bottom. But not too bad for my first try. Unfortunately, we are already completely out of gas, so this is gonna take a while. Alright, so it's actually several days later now. I ran out of oxygen and had to go get this tank refilled. Now, along the way, a subscriber gave me a tip to preheat this plate as much as possible, which would save me a lot of oxygen and help speed up the whole process. So to that end, I went searching through my tools and I found this guy, which I've never opened. It is a weed dragon. It's pretty straightforward. You just get a standard propane tank and connect it up to this torch and then light it. My goal is to get this plate to 300 or 400 degrees. I'll measure with that pyrometer over there and we'll see how this goes. Alright, I'm showing a little more than 300 degrees on top, about 350, 400 on the bottom. I think we're good to go. Alright. That actually wasn't too bad. It went about 3 times as fast as the first cut, so I guess that preheat really helped. Kind of looks a little rougher, but that's mainly because I had to go back over it just a little bit. There were a few spots I hadn't quite gotten all the way through, so I was actually moving slightly too fast. But it worked. I don't appear to have ruined the sword so far, so let's work on these side bevels. Alright, we are all done. I did the 2 side cuts in one go. I'd say it came out pretty straight. Not perfect. I think this one's a little straighter. I had some difficulty at the beginning of that cut way down there. Alright, next step is to kind of get rid of all the slag and all these, majorly rough imperfections on the edge. I'm just going to use an angle grinder to just roughly smooth it out. I found that this crusty stuff is extremely hard and it can really do a number on my milling cutters, so just gonna knock it down a little bit and then we'll drag the thing over to the milling machine. Alright, so a few hours of grinding and this is what we've got. They're looking pretty good. As you can see, I didn't get all of that slag off or carve out all of these imperfections, but I got at least 75% of them, I would say. This is my first cut and you can see it's the roughest side, but not too bad. I don't think there's really any problem areas other than, I think it's this one right here. You can see that it's pretty deep in there. And I don't know if you can see the line. I can't actually really tell on the viewfinder, but there's a scratched line right about there. We'll see. That's probably the closest one. A few others elsewhere, but I think I may have gotten away with it. I also put this kind of bevel on the edge here to kind of just get rid of all the burrs and the slag deposits and everything, so it'll lay flat on the milling machine, and it won't kind of scratch up the surface of the milling machine with, you know, some sort of imperfection on the underside. So we'll see how it goes. All right, so now I need to get this giant 400-pound blank into the next bay of this shop and onto the milling machine. All right, so this is the forklift that I purchased last year. Now, one of the reasons I purchased this particular forklift is because of this mast. On most forklifts, they're intended to lift things up very high, you know, at least 15 feet or so. This has got a tiny little mast on it. It can only lift maybe 8 feet. And the reason why I wanted that is because the mast doesn't stick up above the, you know, the roof line of the machine, which allows me to get it inside the relatively short doors of this shop. The other reason is it's got these very short forks on it. They're only about 3 feet long. And again, it just makes it very maneuverable. It's tight in the shop, so turning with very long forks would be problematic. The downside in this situation is I need something with a lot of reach so I can kind of make a poverty crane out of this forklift. Now, to that end, over here I have purchased some homemade fork extensions, and they give you a lot more reach. Obviously not with the same weight capacity, but that's not important. Here I'm only lifting a few hundred pounds, not several thousand. So these are 7 feet long, and I've drilled holes in the end of them. And what I'm going to do is bridge the holes with this thing. What I've done is I've just taken some scrap round bar and I milled a flat on it, so it'll sit flat like this. Put the holes in the ends, and then I'll join them together with bolts. And from the center, I can then hang a chain fall like that one. And then on the end of the chain fall, I will have this lifting magnet. So I haven't tried this yet. Let's assemble everything and see how it goes. Alright, so my improvised crane idea worked great right up until it didn't. The problem here is you see there's all this slack, but I can't raise the mast anymore or it'll hit that garage door. And I can't close the garage door because it'll hit the back of the forklift. So the goal here is I'm going to have to raise this thing probably as much as possible. I mean, I might as well raise it to roughly the height of the mast itself, so I have as much lifting range as possible, and that'll get this whole thing and all this and this equal to or above the level of the forks, which will give me a much greater actual indoor lifting range. You see over here, I've got some big box tubing that I cut up and I'm going to use for my risers. This is actually the remainder of the legs for this giant welding table that I made, so it should hold up no problem.
2,000 years later.
Okay, well, it's been a few hours of cutting, plasma torching, drilling, grinding, welding, machining, but this is what we got. I've got these two big pillars acting as risers. I've got 1/2-inch plates at the top and bottom. There's a big piece of threaded rod coming all the way through to the top there and just securing everything together. And this has gained me a ton of height. As you can see, this is now the minimum lifting height. We're actually just above the forks, so this is perfect. I'm not actually even touching the plate yet, and now I've got, you know, maybe a foot of space up there or something like that. So hopefully this holds together. Okay, well, that was extremely lucky. You can see the magnet failed. Well, it's not so much that it failed, I realized, but the forks were pushing down on this end while I was lowering the whole thing, and it just kind of pried it right off the magnet. But luckily, it landed right on the table. It didn't damage anything. It only dropped, an inch. I don't even think it was that far, but whew, you can see it was pretty close to coming off the table. Well, I'd rather be lucky than good any day. Let's get this monstrosity out of here, and I'm gonna go to bed. Tomorrow, machining. All right, so we got that blade blank on the table last night, and I'll give you a little introduction to this machine since it hasn't been featured on this channel before. This is an old 1938 Cincinnati milling machine. It's about 2.5 times heavier than my old milling machine. It's weighed about 5,000 pounds and has 2 spindles. You can see one right there. This is the vertical spindle, and then there's a horizontal spindle right there. It really increases my milling capability, both from a power standpoint and just a flexibility standpoint with the 2 different spindles. This vertical spindle here can actually rotate, this way and then side to side, basically. So I can do a whole bunch of things with this. Coming over to the front here, you can see I've retrofitted with some modern controls, and we have a digital readout to read a precise location of the table. All right, so first things first, we have to get the blank aligned on the table. The table moves perfectly straight, left to right, in and out, and I want this edge of the blade blank to be perfectly in line with the table's travel. So as it's milling a perfect line down the end. Now to this end, I had previously scribed a line in the steel. I don't know how well you can see this, but there's a nice straight line going all the way down, because I knew I wouldn't have a straight line on the edge here. This is still pretty rough from the torch cutting. So what I have done here is I stuck a laser in this spindle. So really quick demonstration on what I'm talking about with the laser. Let me turn off the lights and I can show you. All right, I got most of the lights off, and you should be able to see the laser. It's right there at the tip of my finger. I think you can see the line that's scribed on the plate. But now I'll traverse the table about 2 feet, and we'll see if it still lines up. All right, this is gonna be difficult to get this to focus because it's kind of in the dark, but I think you can see there's a line right here, and it intersects with that line, and the laser ended up right at the corner after traversing the table 28 inches. So I'd say we're good and lined up, and let's take a test cut with that spindle and see what happens. Oh, by the way, I've never actually used the spindle in the machine. I know it spins, but I have no idea if it's gonna blow up the first time I use it, so fingers crossed. Okay, so I've gotten this far on my first cut, and I've already run into my first issue. The cutter just keeps stalling, basically. It just completely stops, and I played with it a little bit, and I kept hearing like a belt screech. So I came around to the back of the machine, and I think I found the problem. There's supposed to be 5 belts on this, and there's only 2. Not only that, but you can see there is like no tension on this belt, and just a little bit on that belt. I guess considering it's midnight, I'm gonna try to put as much tension on this belt. There's actually an adjustment knob, it's actually right here. I'll put as much tension on it as possible so I can get as much cutting done tonight, and then tomorrow I'll see if I can source some new belts. Shouldn't be too big of a pain, but you can just see, look at the splits in the belt and everything. These are almost done. Random side note, by the way, check out this door for the back of the milling machine. It's got a way, it's hard to move. Look how thick it is. This is all just cast iron, one big cast iron piece. It's gotta be 200, 300, 400 pounds, I would say. Just for a stupid door. Look at the thing. All right, I put a lot more tension on this now. This is the one that was super floppy. It's fairly tight, and this one is very tight. Probably too tight, but let's see if I can rotate this by hand. Yeah, I mean, it's not terrible, but it's just gonna be for tonight, hopefully. All right, let's get back at it and see if I can't blow this thing up. Okay, so it's a new day, and I've almost got this cut done. This machine can do 28 inches at a go. It's probably 2 inches short. I gave up for the night last night because I kept stalling that cutter out due to the belt issue, which hopefully is band-aided for now. I was able to locate 2 new belts, and I'm using the 2 old ones, so that should be okay for the moment. I've got 5 real ones on order, but it's currently the weekend, and I can't source that many belts that quickly. So back over here, the main problem I'm having is a lack of clamping on this end. I was hoping that the incredible weight of this thing, plus the clamps that I'm able to squeeze in down here, would be enough, but it is not. The issue here is, if there's any real machinists in the audience, these cutters rotate counterclockwise, and so you can almost kind of imagine it's like trying to grab the bottom of the plate and lift it up, and with no clamping down here, it's actually moving, and that is gonna wreck this cutter. It's gonna chip those teeth and break them off in short order. So I've got this hack job set up over here with some welding clamps, which is not great, but I really don't have any other options. This whole thing is smooth on the backside down here, so there's like nothing I can just grab. So I'm literally putting it right underneath this handle, which hopefully should just get me through. Ideally, I would have the machine traversing the opposite way. It would be going left to right. So as the cutter rotates, it's pushing down on the plate, pushing it into the milling machine, which should prevent this issue in the future. However, I wanted to mill this side first, actually this quadrant first, because this is where I had the biggest mistakes with the torch cutting, and I wasn't sure if I was able to machine the whole thing smooth. As you can see, I don't see any of those mistakes here. Everything seemed to machine out, so I've just got to finish this up, and then I'll move this thing around, hopefully a better clamped position, and I won't have this problem in the future. Okay, so I didn't bother filming it, but I finally finished this section of the cut, about half of it or so, and then I got the plate all lined up to do the next half of it. So this time what I've done is I've mostly centered the plate on the table, as you can see, and I don't have this giant overhang. It's just maybe 2 inches or so, and this allowed me to get this clamp in this T-slot here to clamp down this end. I had to kind of clearance the end of the clamps just to get it in there, but I considered putting a clamp right in the middle here, exactly how I have this, but the only problem is, as the table traverses, it's gonna hit this thing right here, so I'd have to take it off, you know, right before I got to that point, I guess, which kind of negates the whole point of having it, because then it's gonna be, you know, directly opposite the cutter right when I'm taking it off. So I'm leaving it off for now. I managed to get just enough clearance so I can actually actuate this, and it just misses the clamp. So we'll see how it goes. Alright, so it's been a few days since my last clip, but I've got one whole long section of the sword done now, and I've got everything, you know, rearranged to do the other side. I was actually just doing a few minutes of cutting before this video. You can see I've got this set up correctly now. The thing is traveling from left to right. The cutter spins counterclockwise, so it's kind of pushing down on the plate, and that has reduced the vibration and the noise significantly, but it did not solve my stall problem. So in regards to the stalling out issue, I have identified the issue. I won't waste your time with all the boring steps I've taken in the meantime, but basically that little box right there is a transformer, and at best I'd say it can support maybe 1 horsepower. However, the motor in that spindle is 5 horsepower, so I'm way down on power. And as a result, this machining is taking forever. I can only take these tiny little cuts. You can see I actually went deeper at first here, but it's just, the machine could not handle it. So I'm just taking this little skim cut now, and I just have to keep coming back for more and more passes. So it's literally gonna be weeks and weeks of machining to get this whole thing done, but there's not really a better option. I have an electrician coming out in a few weeks, and I've got some stuff on order, but by the time I get there, this will all be done anyway. Random factoid, by the way, the table on this machine can traverse 28 inches left to right, and I measured this long section of the sword, and it's just over 56 inches. Given that I didn't want to have to do 3 setups per side, which would take just extra hours that I really don't want to spend, I tried to stretch it and basically position the piece perfectly so I can get all 28 inches of travel on 2 cuts, and you can see how close I came. This is the last bit that I just couldn't reach, but this is not a problem because you can see the line here. This is material to be removed, so I just barely got away with it. Hopefully that saves me a day or 2 of machining and setup and so on and so forth. Alright, that's about it for this update. I'm gonna go back to endless machining and turning this giant steel plate into all these pretty chips.
Many hours later.
Okay, so I've got the 2 long sides of the sword machined here. It actually came out quite well, but the problem is I need to do this side of the sword and then the 2 little angles at the end, these things. And you can tell if I were to rotate this blade 90 degrees so it's facing that cutter over there, the center line of the sword is going to be hanging off into open space out here, and I certainly don't have the strength to hold 400 pounds while I'm trying to clamp the thing down to the table. So what I've come up with is this ungodly contraption over here. So what I've done is I've taken the forklift, I got these 7-foot long fork extensions, my little homemade train hoist thing. What I want is to be able to support the sword, but not rigidly. The idea would have some level of compliance so I can kind of wrangle it into position and then clamp it down. So I actually use this. This is actually a resistance band. This is the largest one this company makes, and I've got it doubled up here. It says it's good for 200 pounds of resistance, so I figure it should be right in my wheelhouse for this job. I've actually already lifted it mostly, and I'll show you if this is just kind of, it's touching, but it doesn't take any effort to move it, which is exactly what I want. I want to be able to position it, you know, smoothly, but not rigidly. And in case this thing breaks for some reason, this gold chain is kind of a safety. It's going right across the forks, and it's looped back around this. So hopefully this isn't a major disaster. Unfortunately, I was not filming earlier, and I was setting up this exact configuration, and I lifted the fork so high that entire thing came out of the top of the forklift, and this whole thing came crashing down on the table, and it almost got me. It actually hit my finger in midair, but no injuries, thankfully. The sword almost came off the table, but whew, it was really lucky. This time around, I have lowered the mast a bit so it cannot fall out and fall forward. There's also a ratchet strap right there with a 10,000 pound breaking strength. Over here, we have our resistance band. This gold chain is a safety to catch it if it falls, and if the magnet fails, it can fall on this table here, the heavy duty fabrication table. Plus, I've got my steel toes on, I've got my safety glasses, and my new fancy hard hat, so let's try not to die. Alright, so I've got the forklift at its tallest point, or at least as tall as I'm willing to put it, and I've got the little chain hoist that I use to lift this thing maxed out, and I actually got really lucky because you can see this is basically perfect. It's just it's just floating off the surface. I can take this end and just one finger move it around, so this will allow me to position it precisely on the mill while still having plenty of support, but just enough give, I guess. So I can get these clamps on this and get this lined up just right with the travel of this milling machine's table, so I'm going to get to that right now. Well, that actually didn't take very long. I can't believe I'm saying this, but the first time I positioned the sword blank, I just kind of eyeballed it. And then when I used the laser to verify, it was exactly perfect. Like, I could not have made it any better. I have no idea, that's like impossible, but anyway, it saved me a ton of effort. So I've got my redundant clamps here, And I kind of eased up on the pressure of this a little bit, especially because it's going to be articulating left to right and I don't want it to pull too hard. I can move the handles of this very easily, just, you know, I mean, it's almost floating. Hopefully this works. Let's get started. Alright, we are on our final pass. We're cutting off our last 1/8 of an inch or so. Getting some real nice, pretty chips down here. Everything seems pretty happy. This whole rig has held up really well so far. I'm pretty happy with the whole situation. Now I just gotta reposition it 2 more times to do these little angles down here. Pretty much the same exact idea. And we'll finally be done profiling this thing. Okay, well this time I didn't get quite so lucky with lining up this side here, and in fact I found it to be incredibly tricky because with the amount of tension on this, as soon as I loosen one of these clamps to reposition the plate to get it in line, the tension actually pulls the plate out of position. So what I did with this, I've got this table on casters, so I lowered the machine's table so they're the same height. And then I'm using this table to support this outboard section of the blade. But then I found that it's basically impossible to shift the blade around because there's so much friction between it and the table. So I have partial tension with the resistance band just to take some of the load off, but it's still sliding, still resting directly on this table. And then every time I would make a pass, you know, back and forth to see if I had this edge in line with the table's travel, I would have to clamp everything down tight, make the pass, then loosen all of them except for one so I could pivot the blade without it being pulled out of position by any of these other things. And it seems to have worked. I've gotten it very, very close and I'm calling it good. So let's get this thing to milling. Alright, that is that. The final milling operation on the profile of the blade anyway. It's getting late and I'm heading in soon, so I'm going to acid dip it. I've got my little container and my liner there. Now what I'm going to use for standoffs to prevent from breaking through that liner are these things. They're just some old scraps that got a slight radius to them, so I'll put them down like that and they'll be less likely to puncture. I also ground down all the corners so they won't dig in. But I may have a giant vinegar spill on the floor in a couple days here, so we'll see. That's it. I've got enough vinegar to cover the whole thing. It's almost coming out of the tray here, but I think that's going to be good enough. Alright, I'm actually going to be gone for a few days, so the sword blade can marinate for a bit. So this has been marinating for about 24 hours, and I just happened to walk out here to check this out and thought this was somewhat interesting. You can actually see the mill scale lifting off, complete with the writing on it and everything. Yeah, that's as close as I can get. You can see it's actually floating on the surface of the vinegar. Not attached, but it's like perfectly complete. Funny, huh? Alright, day 2 of the vinegar bath. Actually getting fairly murky now. I love that you can see the perfect outline of the sword. All the bubbles and debris and everything just kind of stay right in line with the profile of the sword instead of, you know, dispersing throughout the whole solution. Alright, one of the rare times it's actually daylight outside. But this has been sitting here for about 3 days. I would say we are done. I'm gonna take some of the vinegar out of here so I can get the magnet on there, and then we're gonna lift it up and get this thing all cleaned off. Alright, so I've been in here for an hour or two setting this all up. I think I've got everything aligned and ready for my first cut. Now, I had to angle that head to match the angle of the bevel, but if you look here, there's a protractor on the side of the head. We've got 0, 10 degrees, 20 degrees, and this is the reference mark. And you'll see I'm literally missing the little notches just for these few degrees right where I need it. So what I'm gonna do is use this digital angle finder. I'm gonna stick this right on the table. I'll zero this out. Okay, let's make sure 0 degrees, and then I'll just stick it on the side of this cutter here. And we've got 71 degrees, which is, 90 degrees minus 19. It's just the orientation there, but we are dead on to what we need. So I'm gonna take my first test pass here and hope the machine doesn't blow up. All right, it cuts. I just gotta reposition the cutter. Need to back it that way. All right, so I didn't film this because I was doing a ton of trial and error, probably 6-7 hours of work, but this cutter ended up being way too big for this vertical head, so I ended up using this cutter, which is about 1/3 the size, to do kind of like 3 chunks of removal, and then I came back and just cleaned it up with this one, so I ended up with a nice, smooth, uniform surface before there were tiny little steps between each cut. I think it came out pretty well. You can see I'm not right on the line here, but I hand scribed these lines, and they're honestly probably not super accurate. I took the liberty of actually measuring the depth of this bevel. My goal was 2.88 inches, and this is what I came up with. So I'm slightly shy, 15 thousandths of an inch, maybe 3 or 4 human hairs. So I'm calling it good. Chances are any error is due to the fact that this head is probably not angled at the perfect angle. That digital angle finder I had was accurate to, 1/10 of a degree, maybe 2/10 of a degree. So I'm calling this good. It looks pretty good, and it's kind of starting to look like something. All right, so it's time to reposition the blade so I can do this next section of cut here, and I'll use the little cutter and then clean up with that cutter. And it'll probably take me a couple days, but cue up the 1 minute long time lapse. Okay, so I know I said there'd be a time lapse, but there is a slight major problem here. As you can see, I have moved the workpiece over so I can start the cut here, but there's no clamping surfaces available. I cannot get a clamp on this anywhere. Now, the only solution I could come up with would be to push the workpiece towards the machine, thus exposing one of these T-slots so I can actually clamp the thing down. The problem is the cutter's in the way, so I could theoretically move this whole ram backwards, except this vertical head is hitting that clutch lever, so that limits my travel. Further complicating matters, I discovered that this surface that I just machined is not perfectly flat. Here, let me show you. Here, I've just got a little cheapy straight edge on here, but I think you can see that there's light right in the middle of that cut. It's kind of a slightly dished cut. And the reason for that is this head got knocked slightly off center. So the front of the cutter is digging in a little bit more than the rest, thus making a slight depression right in the middle. And if we look at the protractor on the side of the machine here, you can see the 0 right there. And the 0 on this is slightly off. That's all it takes. And earlier I accidentally ran the cutter into a big cut too quickly, and I must have just knocked the machine out very slightly. So I basically had to go through this really painstaking process of aligning this entire head in the, in front to back and side to side. Then set the 19-degree angle again, and if I'm gonna do all that, I might as well just reposition the whole thing, flip it over here so the head's on this side. That way I can push this whole thing back and not hit that clutch lever. So I'll be back in an hour or two. Yeah. Alright, so immediately after that last clip of machining the bevel, I ran into some major issues with this machine. I was unable to traverse the table back after completing those passes, and needless to say, it has been several months since that time. I required complete disassembly of the machine. I had to fabricate new parts. I had to completely rewire the machine from scratch. On and on and on and on. Alright, so long story short, I'm not going to be utilizing this machine. So this is the machine that I'm going with to finish the bevels on the blade. It is a much more robust version of the other machine, and it has a much higher weight capacity, and I think it can solve all my problems. This is a 1941 Cincinnati #2 horizontal milling machine. Now, she weighs about 6,500 pounds. She's got 5 horsepower and hopefully enough grunt to do this sword. I spent the last 5, almost 6 months, a couple hundred hours, couple $1,000 getting this machine up and running. I've got it retrofit with a digital readout out there. I've got some lighting, and I've got this additional table on here. If I kind of squat down here, you can see this is the original table here, right? It ends right at this point, and you can see the bolts that are holding this other table on. Now this is what they call a sign plate.
So the neat thing about this table is it's got these like arms here. You can see it locks with a nut here and it rotates here. And so that means the whole table can lift up like this. And then when the cutter comes in, it's coming in at the angle, and you can use that to cut your bevel.
I actually got this from a locomotive factory, if you can believe. This thing is absolutely enormous. I'd say it weighs 1,000 pounds or so. It's 100% cast iron, and it is very old. Definitely quite a score for doing pretty much any blade that I'll ever come across in the future. Alright, now if I back up over here, you can see how I'm going to safely load the blade on this machine. I've got a new gantry crane, and I'll use the lifting magnet to pick up the blade and drop it onto this table. The other nice thing is I will use that crane. I'll stick this thing in here. Look at that, it even has a nice little cutout so I can get this in here. So I can stick this in here, and then I can use the crane to lift the table up to the appropriate angle. I mean, this top plate weighs at least 500 pounds, plus the sword on top of it, so it would be pretty tricky to get it into position otherwise. Oh yeah, and one other thing I did is I machined these kind of standoffs, or maybe you call them a stop. Basically the idea is I can slide these in the slots on the front. Now these slots are precision machined, and I can put them all in a row down there, and then I can slide the blade up against them so that it basically will allow the edge of the blade to be perfectly aligned with the slot. The slot, it has been perfectly aligned with the travel of this table, so setup time is dramatically reduced. I actually cut these all out of the same piece of material that was machined to a consistent size, so they will all offset the blade exactly the same amount all the way down. Plus, this way when I have the table at an angle and I've got a heavy blade on there, I can just kind of slide it along all the stops instead of trying to like reposition this 300-pound piece of steel that's precariously hanging like that and then clamp it, and it's just gonna be a complete nightmare. I mean, honestly, it would be impractical to do without these stops. So this was well worth the effort to design and implement these. So final note about these things, I had to make them slightly smaller than the slot. I mean, there needs to be some level of clearance so that you can slide them, right? But I don't want them to have any wiggle, right? You can see you can move that around, and then potentially there would be some amount of error among all of them. So what I did is I drilled a hole slightly off center in all of them. The idea being when you twist it, it kind of acts like a cam and it wedges itself into the slot, and then no movement whatsoever. All right, so that was a lot of talking, a lot of explaining. Let's get that blade on there and let's make our first cut. No joke, I have not tested this. I'm gonna throw the blade on there and I'm gonna cut it for the very first time right now. All right, that wasn't too bad. You can see all I had to do was just kind of push it up against my stops, and I'm instantly aligned everywhere I need to be. Let me get this thing positioned side to side, and I'll get it clamped down, and then I'll show you raising it up. All right, so as you can see, I got this all clamped down, but I sort of discovered a problem here. I don't have very effective clamping. Ideally, you'd want the bolt at this end, so it's pulling down on the clamping point and providing a lot of pressure. But obviously with this distance, I can't do that. It's actually even worse over here. And same thing over here. Now I have the T-slot nice and close, but I can't clamp on the bevel. So again, I gotta reach really far. I put 4 of them on there. Hopefully that's enough. And I have 2 good ones down here. This is how it should look. You can see, again, the bolt pulling down right on the end, providing a ton of clamping force, you know, right on the nose of this clamp. So hopefully between the 6 of them, it'll hold it. But I really need to come up with a better plan for that for the future. All right, so it is literally like 2 hours later, and I think I finally got this at the right angle. The reason it's so difficult is I'm trying to pick up the angle of the bevel that I've already machined so that I can continue machining it and it'll all match. The problem is, you know, how to do that accurately, especially with such a heavy piece. What I've done is I've taken this empty tool holder here. It had a nice machined face on the front of it, which you really can't see because I don't have enough room. But the idea is I took an adjustable parallel, which is this thing, often called a planar gauge. Basically the 2 sides of it are flat and parallel to each other. And you just slide this piece up and down to make it wider and shorter. So I just kind of kept sticking it in that gap there, moving the table very slightly, sticking it in the gap there, you know, over and over and over. And then I overshot the angle and I had to drop it back down and then start over again. So it just kind of went on and on and on forever. But I'll show you what I mean here. Pretty tight, but you can see I wedge this in here. It doesn't even fall, it doesn't wiggle at all. I've got it pressed up against the face of the tool holder there, and the angle of the bevel, the previously machined bevel. So I guess we'll call that good. And if it's not perfect, I'm guessing it'll be close enough to, you know, hand modify it, basically kind of blend it all in so it looks the same. Back here on the other side of the plate, this is how I raised it kind of slowly and relatively accurately, just this bottle jack here. I tried using these little screw jacks, but they're just kind of too wimpy. I may pick up some heavier duty version of these and use them in place of this. This worked pretty well, but it's just not great for fine adjustment. And if you go too far, you have to back it off quite a bit to kind of reset, and then you just start all over again. So extremely annoying. I've got some digital angle finders. These were helpful for at least you know, getting me in the ballpark, but they're not super accurate, and they're really hard to kind of fit in that space too, so it didn't really work out that great, but live and learn. We're getting there. Oh, and I just spotted this. This is a slight problem here. The bolt is nice and bent. The amount of force it takes to lift this thing must be much higher than I thought it is. This is a 5/8 inch bolt on a lifting eye, so I didn't think it would really bend, but you know, here we are. Alright, I'm getting there. I'm just about to set up this cut, and I discovered that this lever here for the clutch engagement hits the damn sword, so I'm gonna take it off and reorient it, I guess. Just another little detail that I have to work through, like a million others. Alright, so it is now the next day, and I just wanted to show you an example of how the simplest things can be extremely frustrating. I wanted to switch this lever around, as I previously mentioned, and I cannot. Like, I got the bolt loose, it's just floating around in there, and the shaft itself is loose, but I cannot separate them. I've tried everything. You can see the paint is missing over here because I was using pipe wrenches to try to pull it off. I tried hammering this thing out of here. It does not go anywhere. I can only think that the bolt is bent, and that's why I can't actually pull it all the way out of the hole no matter what. But I went with the simple solution, which is I just torched the hell out of it and then manually bent it the right way. It's a hack job, and I'm not a fan, but I really didn't want to spend the rest of my life trying to figure out how to get this stupid lever off there. So here we are. I pull the lever down. This is actually as low as it goes. It does not contact anything, so mission accomplished. Alright, so we've got the tool touched off here. I think you can see little scrape marks. That's on the original cut where it's basically perfect, so right where I want to be. And I'm going to kind of clean up all this, you know, all these steps from the previous milling. Hopefully it'll match up, but it should take me out to right here. It'll only take 1 or 2 passes, but I wanted to do a light cut to start with, you know, just to test out this whole thing. I have no idea how rigid the setup. I don't know if these supports are rigid, you know, the whole thing. So we'll see how it goes. We'll take it slow, go shallow, and then we'll kind of keep ramping it up over time.
Approximately 10 hours later.
Alright, so I've sort of skipped ahead here. I've done the machining on the 2 large bevels, you know, excluding the tip here. I haven't done the underside at all, but it's basically trying to dial in the machine, make little adjustments here and there for each section, and I've kind of slowly improved the cutting speed and efficiency and also the surface finish. And I feel like I have it pretty well dialed in here, so I'm gonna resume the video at this point, I suppose. Semi-interesting side note, but this section is a section that was cut several months ago, I think about 7 months ago now, at the beginning of the video. And then you can see where I kind of had to pick up the cut with the new milling machine right here. And you can almost kind of see the journey here. Very rough cutting. You can see all kind of marks. It feels fairly smooth, but it is, you know, that's just a really ugly surface finish. And I'm just trying to get the speeds right, trying to get the feed rate correct, get my clamping correct. I was experimenting with different cutters and everything. This is the second section. You can see it is getting much better. It feels very smooth now. There's a little bit of roughness here and there. I was actually pushing the machine a little too hard at this point, and you can kind of see, I can't really tell in the viewfinder, but it's got this weird like dimple look to it that's caused by chatter. It's just, when you're pushing the cutter too hard, it'll kind of vibrate very slightly and it'll leave this ugly finish. And we finally come down to the last section that I milled, and you can see I've gotten it pretty close. That looks pretty nice. There are scratches in there, and that is simply a matter of one of the teeth on this cutter got a chip in it. So it just kind of left this somewhat unsightly finish. Unsightly finish. It feels like glass though, so I think we're 95% of the way there. Now, speaking of cutters, since I had to kind of break down this whole setup so that I can flip the sword over. I took the cutter out of the spindle, and that's when I discovered that I had a chipped tooth. But I've been getting this sort of, I don't know, kind of a clicking sound sometimes, and a little bit more vibration than I would like. Now, this is an old arbor here, or shank if you prefer. Got some rust on it. I've got the cheapest Chinese cutter head possible. Now, these teeth are actually very high quality, but they're really the wrong one for this application. These are what I use for cutting hardened steel. So I just kind of bit the bullet and spent some real cash, and I've got this thing now. It's the same size, same format, it takes the same teeth, but I've got a brand new arbor. I've got a much higher quality cutter head. This is Toolmex, I believe, made in Poland. And you can actually kind of see how much beefier it is. Like this section here is just so much taller and thicker and heavier. And one of the weird things about this is it has unevenly spaced teeth. I don't know if you can really see, but they're not all the same distance apart. You can see like this one is a very short bit here, but then it's much longer over here. And that's kind of designed to eliminate vibration and such. And hopefully that kind of helps me out there. Finally, I've got some brand new carbide inserts. These are the cutting teeth themselves, and these are really designed for heavy cutting of, you know, more standard steel. So I'm thinking with this whole package, hopefully I'll have eliminated the last of my noise and vibration issues. And I'm honestly curious, you know, what kind of difference it really makes, but I guess we'll find out very shortly. Oh yeah, one last thing here. I'm gonna film most of the setup for the second side of the sword, just to kind of show you the process and how much work is involved and all of the improvements I've sort of made along the way. The whole thing is 5 times more difficult than doing a smaller sword, so I just thought it might be slightly interesting to the 3 machinists that actually watch these videos. Alright, so first things first, I literally just have to flip this thing around. It's not a super easy task. There's no really easy way to do it. There's nothing really to grab with the hoist or anything, so I tend to just kind of flip it by hand, and hopefully I don't drop this on my feet. Getting much easier to slide now. Ugh. Starting to actually lose some weight. Alright, so as you can see, I have articulated the table as far to the left as possible. This is the limit right here. And then what I do is I just slide the sword until it's just going to clear the cutter. The idea is I have the cutter spinning and it will enter the workpiece here with relatively minimal loss of, you know, travel of the table. The table can travel 28 inches at a time, so I'm going to have to move this workpiece and re-clamp it and everything 3 times to get it all the way to the end of that bevel over there. So I'm trying to minimize that amount of work as possible. And as a result, you can see a significant part of the sword hangs off the edge, which is extremely terrifying. It's pretty tippy, but it stays, as you can see. I'm trying to leave the thick part of the sword, the widest part on the table, to kind of act as a counterbalance. It'll be fine once it's all clamped, but obviously it's nerve-wracking as you're handling this 400-pound piece of plate steel. Alright, so next step is I take these stops that I fabricated earlier, and I'm just gonna, you know, slide them in here. And then I'll get, you know, maybe 3 of them on there, and I'll push the plate right up against it so that it's registered against the stops, and then I know the edge of this blade is more or less perfect with the travel of the table, so it'll make a nice straight cut without too much fidgeting with a 400-pound hunk of steel. So this is kind of a traditional milling clamp. It's commonly called a strap clamp. But basically you set it up, you clamp on this end, and you got these little kind of risers, and you just tighten this bolt, right? And it's just gonna pull this end down and give you a pretty fair amount of clamping force. But I just wasn't a fan. I feel like these are a little too little for this sort of job. So I came up with these. I had some of this 1/4 inch thick wall, 2 inch square tubing, and I just drilled some holes. And as you can see, I allowed me to clamp with a great amount of clamping area, but also safety, meaning if something ever happens, the sword is going to have a real hard time falling down and landing on my feet, basically, because even if these are finger tight, right, the sword cannot come out of there. So no matter what the situation is, I try to have at least one of these on here just to make me feel better, I guess. Oh, I nearly forgot. So if you remember, this is my old lifting eye, and it bent pretty well the first time I used it. So I spent a few dollars and I got a proper swiveling lifting eye here, and this thing is rated for 4,000 pounds, so I think it'll go much better. Alright, I've got the table lifted pretty high. It's kind of precarious because once it gets to a certain point, the weight of the blade wants to swing this whole thing forward and smack into that cutter, so I kind of have to hold on to it while it's raising, and it's terrifying. So this is what I've done to set the height. I took off the original top and I ground this down, and I put a hole in the bottom of this, and I also carved this off for clearance. You'll see here, but you can see I had to clearance that edge. So basically, the reason why I taped this is because I just wanted to not move at all. If this rotates, it's gonna increase or decrease the height. But I already have it set exactly where I want it. So I'm just gonna do this. I'm gonna drop the table right on this thing, and then I'll know that the angle of the plate is exactly as it has been for every other cut. All right, let's see here. Almost. I think it's just stuck, and I have to just go like that. You couldn't see what I did. I just kind of grabbed it and moved it down. I think it was just bound up a little bit. Can't move this thing, so it's got all the pressure on it. So we're looking pretty good. Next step is to basically clamp all these things in place, these kind of side arms here, and you know, to add some rigidity. I'll go put the camera back in the tripod for that. All right, we're looking pretty good here. The thing is still nice and secure. I know we have the correct angle. I tightened the hell out of these things. Now, I ended up adding a second bolt here. Previously, there was just this one bolt, and it was right in the center, and I kind of figured that may have acted as like a pivot point, so to speak, and allowed some sort of flexing. And so doing it this way with two bolts, I can move the clamping loads closer to the edges and also kind of eliminate that pivot point. I don't know if it actually does anything, but what are you gonna do? This is probably the weak point of this. You know, this is 1/2 inch thick, but there's quite a bit of material cut out in the middle here, and it's probably just not as rigid as it could be. Now, I have considered upgrading these, maybe fabricating some new ones, maybe out of some, you know, thicker material, maybe 50% or even 100% thicker, or using a hardened alloy. I'm guessing these are probably just mild steel and they're pretty flimsy, but I figure by the time I actually fabricate these and so on and so forth, I could have finished the blade. Quick note while I'm editing this video, month later I did in fact end up getting new brackets laser cut out of some much beefier heat treated chromoly steel. Massive improvement in rigidity compared to the old ones. Alright, that's plenty of explaining. Let's get on with the time lapse. Alright, I just wanted to mention something real quick here. You can see this massive pile of chips. It's kind of hard to gauge how much is really there. If you look, this is, you know, the way, this is the part that this whole saddle rests on and moves on. So it continues out the other side, and it's right about here. So that's quite a mountain of chips that are piling up. But the fascinating thing to me is just how hot this is. If you look at the color of these, I would say this is 600 or 700 degrees Fahrenheit. And even with this kind of thin glove on, like, I can't really put my hand too close. It's like a campfire or something like that, like a smoldering campfire. The amount of radiant heat is absolutely insane. And you can see how it's just kind of cascading down onto the machine and the floor and so forth. So it's actually melting the soles of my shoes. You can kind of see here, they're all embedded in there. And it makes it extremely slippery because it's a smooth concrete floor and I'm walking on, you know, smooth metal chips basically. So I've almost fallen several times. Just a little insight into the life of a machinist, things that you wouldn't really consider. All right, so here she is. This is all the large bevels machined, top and bottom. They look pretty good. I've kind of half-assed measured them and they're within, I think, 30 thousandths of an inch, side to side, top to bottom. That's 0.75 millimeters. I would say that's pretty good considering the scale of this thing. I've got these kind of rough spots here where, you know, I transition from one cut to the next, but there's nothing really there. You can't really even see anything or rather feel anything. It's just, you can see the difference in the cut, but I'll blend this all together. It'll look very uniform, but I gotta do these little tiny bevels just at the tip here. And I was just realizing if I use my little standoffs over there to, you know, line this up, the majority of the sword, because it's so long, is actually gonna be hanging out the table, which is gonna be a slight problem trying to get this thing in place. I can't really hold a, you know, 350, 400 pound piece of steel while I'm clamping it down. So it's getting really late. I'm gonna ponder this a little bit and I will come back to it tomorrow. What do you think there, girl? Okay. All right, so this is what I ended up with over here. I've got the giant lifting magnet attached to the hoist. I've got an extra little bit of safety over here. This is a 10,000 pound ratchet strap. The idea being, you know, while I was positioning this, my feet were directly underneath this. And even though I wear steel toes, that could certainly be a grievous injury if this landed on me, especially on one of these edges, right up against my legs or something like that. So I was slightly nervous and I didn't really want to bother filming it because it took me about 3 hours to do this. You may think this little clamp is overkill after having these two giant ones on here, but the problem I'm running into now is I have removed so much of the sword that the sort of internal stresses of the sword from the original, you know, process of making this plate have caused this to warp a little bit. So this end was actually coming off the table a little bit, even though I had these monster clamps on it. So this is just holding this down to the table. It's not really actually doing anything else. I'm gonna have to get creative with my clamping as I continue to go on here. There's not really any way to straighten out this giant blank, at least not with the equipment that I would have. All I gotta do now is pick this table up, set the angle, tighten everything down, and then we can finally get to milling. Maybe I can do this one corner in, you know, maybe 4 hours or so. Yeah, good times. All right, I am bringing you back early. I've already run into a new snag. I can't lift the table high enough. I had to use these 2 jacks, I believe the 10-ton jacks. I had to kind of turn one, then the other, then this one again to get it into position so I could get that one in place. The hoist was actually stalling out, and I'm not really sure why. It's got a 1,000-pound capacity, but it just wouldn't lift it any higher. I think what is happening is there's so much of the sword sticking out over there that it's putting a lot of pressure on these 2 hinges to the point where the friction is so high, the hoist can't lift it. Like I said, it can only do 1,000 pounds. Even crazier, if you come over here to where I need to operate the machine, this is my perspective. This is what is above me when I need to walk under here. And it's slightly terrifying. It's just kind of this giant guillotine sticking out into space directly above my head. All right, well, I don't know if you can really see this, getting very crowded in here, but I've got my first pass all set up. We're ready to give this a shot. This thing's hanging out here. I've got everything tightened down. I ended up purchasing another one of these screw jacks, so I've got them kind of lightly snugged up to just add some more rigidity to this whole setup. This is still nice and tight, it doesn't move, so the weight is still on there, my angle is still correct, but I've just got a little more reinforcement than just these side things, so we'll see how that goes. Alright, so I've got the 2 little bevels done on one side of the sword anyway, and I noticed a problem. Now, if you've watched my previous videos, you'll know that I like to show my mistakes. I only show some of them because, you know, I don't want my videos to be 30 or 40 hours long. But I'll take you in here. If you notice, so this bevel transition here, this nice line, you know, it starts at this edge here, right at the corner, and then it meets the corner of the blade almost perfectly. That is pretty nice. I'm happy with that. And the same thing with the center line. Comes down and it ends, you know, that is pretty close, pretty close. But then you come over here and this is right on the corner, but then it comes down and oops, it misses by about 3/16 of an inch. I honestly can't even figure out how that happened. I accurately measured like this distance versus this distance versus this distance, so on and so forth, and there was less than 2% variation in any of the measurements. 2% variation isn't super great for, you know, an accurate machine job, but for a sword that, especially something this size with, you know, this many cut transitions, you know, 3 transitions per side to do all the cutting, that's not bad. So the question is, how did this happen? And my only theory is that it's the warping problem from before. When I was doing this cut, I couldn't get any clamps, you know, on the tip of the blade. There was nothing to grab, and the clamps were all kind of back here. And if you'll notice, even just sitting like this, there's a little bit of gap. You can see the gap under the table. You can see a little bit of daylight under there. So my theory is the blade may be kind of C-shaped or banana-shaped, and so when I clamped it down here, it exaggerated that gap. It lifted up either this end or even just the corner. And if this corner was lifted off the table, more of this corner is going to be in the cutter, and it's going to remove a little extra material from this edge. And you can even see that that's what happened. If you look down the line, you can see there's a little bit of a step as it hits right on the edge there. This edge is slightly lower than the rest of the blade. Anyway, I'm gonna flip this blade over. I'm gonna do the last 2 mini bevels there. And that's gonna be it for the blade machining.
Several days later.
All right, here she is in all of her glory. Look at that. I have to say, I'm pretty pleased with the appearance of the thing. It actually kind of looks funny on camera. The forced perspective of the camera is making this end look really thick. Let's try the other side real quick. Oh yeah, now we're talking. Except I can't really even get the whole thing in the shot. There we go. I'm holding the camera above my head, really high up. Yeah, anyway, you get the idea. Little thing is too big to really film it correctly. All right, so back down to business. So this bevel here, it ended up coming out basically perfect. I don't know if you can see that, there we go. Oh, it's really hard to show both sides. This is just kind of the light and dark thing. But I think you get the idea here. That lined up nearly perfectly. All right, the tip here came out really well. All 4 bevels kind of come together almost perfectly. I don't really know if it's coming out fuzzy or not. It's really hard to tell in the viewfinder, but that looks pretty good. Can I do this? Can you just focus? Yeah, there you go. That looks a little bit better. About as close to perfect as it's gonna get. And then we come over here. So, did not line up with that edge. The line is to this side of that corner. And what's doubly confusing is it's actually the opposite of what it was before. Man, I don't know if you can see that. Basically, the line is right there on the right side. And while this one is offset on the left side, pretty much the same distance too. So it doesn't really make any sense. How is that even possible? I went ahead and I measured from the tip to this point, the tip to that point, exactly the same. You know what? Is the angle on one of these wrong? Let me get my little protractor. All right, let's see what we got here. Just a cheap digital protractor, basically. All right, let's see if we can get this lined up. That's pretty close. Touching on both sides, 150 degrees. Let's check the other side, the good side. Okay, let's get this lined up a little more that way. I'd say that is just about perfect. So, yeah, I mean, it's the same thing. It's, if, at most, we're off 1/10 of a degree. And I'm really not holding this just right. It's kind of hard to do this while I'm looking at the viewfinder, but you get the idea. Fascinating. All right, well, I don't know. I kind of give up, I guess. I really don't have any idea how that happened. I was kind of hoping that they would both be off by the same amount. You know, they would line up at least. So then I could adjust this angle, you know, kind of feather it in with a file or something so that, you know, this edge, and this edge all meet on the top and bottom, but it's just, it's not gonna happen. I'm gonna have to kind of sand this part, kind of push that line over just a little bit, and then do the same thing on the underside from the other side, and kind of make them meet, hopefully all together. That's gonna be, that's gonna be tough, but it probably won't look as crisp as it does now, but I'm not really sure what else I could do about it. I'd rather have that line be a little bit, you know, rough, a tiny bit wavy, and have everything line up. I think that'll look much more satisfying, and it'll be less likely to notice, you know, a slightly wiggly line versus, you know, this not meeting with this corner. That's very apparent to the naked eye, and it's actually very slightly worse than the other side. It kind of comes out, yeah. That's weird. It's actually a little bit less. Which actually makes even less sense. You'd think, you know, it would be off by the same amount on both sides, assuming I made some sort of error, but man, whatever. Anyway, moving on. All right, so it's very late, and I can barely even think right now, but it's time to weigh the blade. Now, if you remember, I predicted the sword, I think 325 pounds, and obviously this is just the blade, so I'm gonna guess probably right around 300 pounds. My best guess, you know, after we add the handle, the pommel, the handguard pieces and everything, I'd say it's probably 25 pounds worth, so yeah, 300 pounds. I've got this zeroed out. It's showing a negative weight because it includes the magnet, which is now stuck to the sword, so it's not actually, you know, weighing the magnet. This must be in kilograms, right? Because the magnet is pretty heavy. The magnet's like 50 pounds or close to it, so let's see here. Alright, we are not touching the table. You can't see, but it is not. And can you see this? Yeah, 137 kilograms. That is just over 300 pounds. I'll put the number up on the screen here. when I actually edit this video. My math isn't amazing at this time of night, but let's call it 300 pounds. Is that? That can't be. Did I actually guess it right on the button? Huh. Well, I guess we'll see how I do once I actually weigh the completed sword. And it would be pretty funny if I actually guess both of them correct. It's gonna be really close then. That's too funny. All right, I'm going to bed. Till next time. So next steps here. Let's transport this thing through the demolished doorway and get it on a workbench. And I'm gonna, again, work on these lines and then fix all the little imperfections here, kind of make everything a little more consistent. And I'll bring you back. I'm gonna actually do a black oxide treatment on the sword now. It's not gonna be the final one. I just kind of want to get an idea of what it's gonna look like, because if you've ever seen the anime or read the manga, the center of the sword is kind of unfinished, I guess. It's, as a blacksmith, is probably my best guess. So I want the surface to be kind of convincingly rough, in sharp contrast to the nice bevels, just like the real Dragonslayer. Now, if I bring you in here close here, you can see this is the factory finish. This is the hot rolled finish, and it's pretty rough, but I'm not sure if, you know, when I blacken it, is it gonna wash out that texture, or is it gonna highlight it? So I don't really want to mess with this surface until I have a good idea of what's gonna happen once it's blackened. So long story short, we're gonna blacken this as a test. I'm gonna hand sand all these bevels to get all these imperfections out. It's taken some damage in some spots. One right here, there's a little nick. And if you follow this, it leads to more nicks. I'm actually probably gonna have to weld in these ones and then sand it all back. It just comes from, you know, this sword weighs so much. The steel is relatively soft. Well, as soft as steel can get anyway, but moving this kind of weight that's relatively soft into solid things creates all kinds of little dings and nicks. There's even one right on the tip here. It's right, you see it? Yeah, it's right there. I think what happened is I just kind of pushed it into one of the clamps, you know, the clamp that was sticking up out of the table, and that's all it takes. Oh, and one final thing, I wanted to bring this over to this table so I could inspect it, and I'm curious how much it had warped. And the answer is not much. Let's see, yeah, you can just see right as the camera gets level, you can see a little bit of air under this end, and then a little bit down that end as well. So it's kind of cupped upwards very slightly. Let me just test that out real quick. All right, so I just got a standard piece of paper. It's actually very thin paper, but it's probably 3/1000 of an inch thick or so, and I just want to see here. It's getting pretty hard to move now. That's pretty much it. So it's kind of sticking up in the air a very tiny bit, you know, for the last foot of the sword maybe. Let's try the front of it here. All right. Oh, not very much at all. Just a few inches maybe. It's really just this part of it right here that's in the air. I can't get it any further than that. So that's pretty good, I guess. Yeah, I can't really see any air under there. I'm really not gonna try to bend it. This thing's 2 inches thick and it's off by such a small amount. I mean, I would just have to bend it probably at that point where it starts to curl up. So it would be like right here. I can't even imagine what kind of force it would take to bend this thing. It's 14 inches wide and 2 inches thick. So I don't know. I would probably need like a 100-ton press, something like that. I have a 20-ton press, but I've come pretty close to maxing it out on just 1/4 inch thick material before, and this is 8 times thicker than that. So yeah, not gonna happen. All right, so Believe it or not, I've actually been standing here for about an hour trying to figure out how I'm going to do this bevel, or rather fix this bevel, and minimize the risk of screwing up, because if I screw it up, it just gets really, really complicated, because it's difficult to add material back without re-welding it, and I can't ruin this part, you know, this line here. I don't want to ruin the outside line. Furthermore, clamping on a double beveled surface like this is really difficult, because even if you get a clamp that can do that you know, compound angle, like this guy over here, I tried this. The problem is when, you know, you're squeezing down on two surfaces like this, it just wants to slide off that way, and I couldn't get a good clamp. So I've got two switchable magnets here that is not going anywhere. So I'm starting at the top of the original bevel, and then I'm kind of moving it over so it exactly matches the bottom bevel. You should be able to see that. There's the bottom bevel right there. It's a little dark, but get it lined up just about right with that bar. So I just got to remove this little hump right here. This edge is going to get a little weird, but I think I can you know, blend it in and it'll visually look correct. Now I could use an angle grinder to do this, but I'm actually just going to use this. It's a random orbital sander, and one of the nice things about it is it's variable speed and it doesn't remove material very quickly. So I don't want to overshoot this and really make this edge too thin, and then I don't know what I'm going to do at that point. It's going to look all wonky, and the only way to fix it would be to re-weld the whole thing, fill it all back in, you know, remachine it or sand it down. It's just going to be a complete nightmare. So I pretty much got one shot at doing this and having it look pretty good. So cross your fingers for me. Alright, so 2 hours later, I think we're looking okay. My plan of using the steel bar as a guide ended up being a complete and total failure. I'm not quite sure what happened, but I ended up with a divot, a shallow divot, perfectly parallel with the bevel right here. In fact, you can still see the edge of it right there. I can almost catch it in the light. There's a very slight divot there. I'm just leaving it for the moment. But I think what happened is, by having the guide here, when the sandpaper pushed up against it, it just kind of curled up the edge of the sandpaper and it dug in right in front. So basically, I took my guide off, I just drew a line, and then I hand sanded and hand filed it until it was just about right. And if I catch the light, you can actually see where the divot was. It's just very, very slightly. Now, did I line it up right? Yeah, that's pretty good, I think. I think it came out not too bad. Now, this is not the finished product. I kind of did like 90% of the work here, but truth be told, I'm going to be sanding every surface to get all these milling marks out and everything. And plus, I have the rest of the sword to build. So at some point, I'm going to screw something up on the sword. I'm going to, you know, get a little dent or a nick somewhere, and I'm going to have to repair it. So my goal is to just get it to 90% for now, and then once the sword is completely done, I will finish the bevels and the edge, you know, the edges and everything. Make sure everything is absolutely perfect before I pack it up and ship it off. But yeah, so that was a waste of a night, but at least I didn't totally screw it up. Now let's get onto the black oxide testing. I have cleaned up the surface. I kind of sanded it lightly, scotch-brighted it, and degreased it and acetoned it, you know, maybe 10 or 12 times. I just want to make sure there's nothing on the surface, no oils or anything that will affect the treatment. This isn't going to be the final treatment. I just want to see what it looks like. You can actually see how rough the factory mill surface, finish basically is. It's extremely rough, and I'm hoping that translates with the black oxide. If not, I'll have to artificially, mark up the surface more, but I think this is a pretty good starting point. Oh, and you'll notice the plastic sheeting on the table. The simple matter is black oxide is a form of rust. I mean, it's an oxide, right? And the product used to create that can cause real rust if you don't get it off. And I don't want it running into these T-slots on the table because it'll start the rusting process, and it's going to be really hard to clean these out, effectively. So hopefully this works. Now, normally I'd be doing this outside, and I'd kind of hang the sword up, vertically, and then spray it down. But I don't really have any way of grabbing the sword very well at this point. And not only that, but it's the middle of winter, so I really don't want to be outside in the 20-degree weather with like a hose and everything. So hopefully this works. It's going to get all over the floor, but I don't think this floor can really get too much worse, so I think it'll be fine. Alright, so here we go. That was 3 black oxide treatments. That's usually about as black as it gets. Yeah, it looks pretty good. The black is consistent. I don't see any splotchy areas. Now, the texture is still there. If I bring you in closer, looks pretty good, but as I suspected, once you get a little bit of a distance, it just kind of washes out. The black is just kind of evening everything out. So you can see a little bit, but it obviously doesn't have the texture of Guts' sword as displayed in the manga. So I'm gonna have to come up with a plan for at least lightly texturing the whole thing. Not sure how feasible it'll be to actually texture the whole thing. I mean, ideally I would just kind of heat the whole thing up until it's glowing and then hammer the hell out of it like any blacksmith would, but that would be an extremely tall order to actually get this thing hot enough to do all the hammering while it's still hot. It's just not really a reasonable solution, I guess. So I'm gonna probably do some cold hammering, and I've got some ideas for that. At least this is a good test of the blackening and a good benchmark for the texture. Now, I'm sure the black oxide got under this. It's just painter's tape, but yeah, not too bad. I'm just gonna sand this off real quick and then get back to the real sanding, the finished sanding, so we can get an idea of what it's really gonna look like when it's done. That's a start, at least. Alright, so this is just a standard boring sanding clip, but I wanted to include it because you can see just how rapidly and satisfyingly the sword transformed from just a little bit of cleanup. Alright, so I let the oil dry overnight just to try to get a realistic look, more or less, of what it'll look like all the time. And I think we're there. It's slightly mottled. It's got some texture to it, as forged. It's not perfect, but that's kind of the point. It's meant to look like a, as forged section of the sword, right? I also lightly sanded the bevels just to kind of give a little bit better contrast so I can get an idea of what it'll look like when it's done. Obviously, there's still all these semicircular marks everywhere, but for this test, I think we are looking pretty good. I doubt I will actually try to retexture this at all. We're calling it good. Let's move on to the next step. Okay, so what I found that works best here was to alternate between the belt sander and the random orbital sander. The belt sander removes material more quickly, but it's easy to dig into the surface by accident. The random orbital sander makes blending out those dig marks easy, and the constant switching off of the machines help keep the motors from burning out as well. Alright, well that's, 20% of the sword done. Maybe 3 or 4 hours of work. I was not expecting it to be that difficult, but I guess when you really think about it, the vast majority of the swords I've made had like a 1/2 inch bevel. This has a 3-inch bevel, so we're talking literally 6 times as much material to work on. Plus, the sword is one of the longest I've made, so there's a ton of material here. I mean, the Buster sword had a big bevel as well, but it was, significantly shorter, and it only has 1 edge and not 2, so still less than half the work of this thing. So anyway, long story short, this is as good as it's gonna get for now. I've got this at an 80 grit. You can see there's quite a few scratches in it, but I'm gonna finish the rest of the sword first before I really try to make this very pretty. Honestly, in the end, it'll probably be 120 to 220 grit. I'm not trying to make this polished and absolutely stunning. That's not how it ever looked in the anime or manga, even when it was new. So what you're seeing is actually pretty close to what it's gonna look like when it's done. If we look down the line here, you can see it's pretty good. Very few defects. The lines are almost perfect. There's a few little problems here and there where, I kind of just dug in just a tiny bit too much, but the edge is nice and straight. I'd say it's good enough. You can kind of see over here in contrast all the milling marks and everything and the roughness compared to this. This is so much better. Now I just have 12 to 15 more hours left. No big deal. Honestly, in retrospect, what I should have done is when I was milling this, I should have kind of taken a final pass, a really light cut to really make the surface finish nice. I didn't realize how much work this would take to get these kind of rough machining marks out, especially over such a huge amount of square footage. A little late for that now, I guess. Okay, well, that is it for now. I've got this whole thing top and bottom sanded to 80 grit or so. It's not perfect, but I have gotten all the milling marks out, and I've gotten all the, the imperfections out. Well, I should say there were 2 left over, actually. There's one right here. The problem with this is if I fill this in with weld and then sand it back, I'm gonna have a smooth spot on the top of the surface, and it'll be essentially impossible to kind of replicate this texture, and it'll look really out of place to have this smooth section right here. So I hate to leave any of my swords with any sort of imperfection, but I think that's just gonna have to stay. It is full of grinder dust, which is making it stand out, especially against the relatively shiny surface here. I'll probably kind of wire brush it when the sword's finally done and just get it nice and clean. It's not quite so obvious. I may go back and even sand it very lightly. I'm probably gonna make it worse, so maybe I shouldn't. Only other remaining issue is on this side of the sword. There's a tiny nick in the blade. This is where it hit one of the stops on the milling machine, and it's just such a thin surface with such a heavy blade, it actually kind of dented it. It mostly came out through all the sanding, but not quite. However, I'm not actually concerned about it at this point because all of this hand sanding has removed enough material that this edge is extremely sharp, and I really need to file this down because it's out of control dangerous. And when I file this edge slightly, that is going to disappear, I believe. So overall, I'm pretty happy. I realize that's all very nitpicky stuff, but that's who I am. What's crazy here is all this hand sanding, the amount of hours I have put just into getting these milling marks out of here and kind of making everything look, relatively uniform. It's about the amount of hours it takes me to make an entire smaller sword, like say the Raider sword, from scratch. The whole sword, soup to nuts, you name it. All that time just spent on just hand sanding these bevels. So it's been about, 3 weeks I would say since I finished milling this, maybe even 4. It's kind of amazing to really think about how much work that was. Anyway, enough rambling. Let's leave the blade for now and let's go make some other parts. Okay, we had a small piece to make this time. You can see what I'm talking about. This is the little eyelet and single chain link that Guts uses to carry the Dragonslayer on his back. Now I'm kind of running out of time on this project, but luckily I was able to source some parts that are very close, and I think I can modify for my purposes. I've got this eye bolt here. This is pretty close, it just needs a little bit of shaping. Now underneath the eye bolt is a very thick washer that's sort of got a taper on it. I was able to source these very thick washers that I can kind of like manually shape. As you can see here, the washer is like a slightly higher diameter than the eyelet at the end here. I would say that's a pretty good match. Last bit is the chain link. I kind of went through my scrap pile and I found this. You can see it's about the diameter of the washer, and that's pretty close. We've got the general proportions. I'll just have to cut this chain link off. I'll leave the slit, as you can see, it's not like welded back together. I guess Godot doesn't have, you know, a MIG welder hanging around, so I'll have to pay attention to that detail, but this is a really good start, I think. First things first, I figure the simplest thing is that washer. All it needs is just a little bit of a tapered edge, and all I'm gonna do is this. If you've seen this channel before, you've seen me use this method. Basically, I've got a bolt through the washer with a nut backing it up, and I'm gonna use this drill to spin it against a belt sander, so I can just kind of manually shape that edge so it's just more of a radius than it is just a, you know, a square edge. Should be pretty simple, hopefully. Not too shabby, I would say. I got that taper, you know, whatever, radius edged. Pretty much exactly how I wanted it. Alright, so that turned out pretty well. As you can see here, there's a little ring at the top. That's where the bolt head was covering the washer, and I wasn't able to sand and polish that part. Wasn't sure how bad it would look, but I'd say that's fairly noticeable. So I tried a few different methods of holding this washer, but nothing I had really worked quite the way I wanted it to, so I just used some super glue and glued it to this cutoff here. This is actually the end of the handle. I had some excess material, and it ended up being almost exactly the right diameter, so here we are. That's on there pretty good. I've also used my glue gun in the past for jobs like this, but I can't find it, so super glue it is. Alright, that's much better. You'll notice I ditched the polished look, even though I spent forever getting it perfect. I kind of like slept on it a little bit, and I realized that nothing on this sword would really be highly polished and beautiful. This is, you know, still very nice, but it's more of a satin finish. I think that'll do just fine. Same sort of idea here, that satiny Scotch-Brite type finish. This was way more work than I anticipated. The eyelet was very rough, kind of like as forged, and took quite a bit of sanding and shaping it to get it to where it is now. Like these areas under here, like right between the washer and the eye, it's just kind of a really tough spot to sand, but I think it came out okay. I also gave it a kind of a slight radius. It's not perfectly square. Looks just about the way I wanted it. Let's work on that chain link now. Alright, so normally I would use a bunch of heat to twist this chain link and get it off the rest. But this is galvanized chain, which is a zinc coating, and vaporizing zinc can be extremely hazardous to your health. So I made a little slit with a bandsaw there on that link, And I'm gonna try to bend it cold with my biggest wrench, so hopefully this goes a little easier. Yeah, what do you think? That actually wasn't that bad. Just got a minor cramp in my abs, but what are you gonna do? I'm old. Alright, I just kind of hand sanded the weld off of that chain link, so it's just kind of a cleaner appearance, I guess. Yes? Can I help you? What do you think, girl? Now, I have discovered a problem, and I did sort of anticipate this. Let's see if I can do this with one hand, but as you can see, there's plenty of clearance in there. However, when you try to turn the corner, I can't pass it through there. It's kind of jamming up. What I'm going to do is I'm going to clearance the outside portion of the hole on both sides, kind of give it a taper so that there'll be just enough clearance so this can round the corner. So it needs to be down here, right? And I can't get it all the way on, so that's what we'll have to do. Alright, one last step before we put this chain link on that. I want to get rid of that galvanized coating, so I'm just going to stick it in some vinegar, probably overnight or so. That should get it off. I seem to remember it will, but I guess I'll find out tomorrow. Alright, it's been about 24 hours. Let's go fishing here. And let's see what we got. I'll hit this with a little Scotch-Brite first. Merry Christmas, by the way. Alright, there we have it. Scotch-Brite it off. I'd say it looks pretty good. I think it's a good match color and texture wise for the rest of the pieces. Guess I'll close up that link and call that part done. Not bad looking if I say so myself. Alright, this may seem a little silly, but after reviewing the footage, I thought the eye of this eye bolt was sitting a little high. So I trimmed the shaft down so the washer sits higher. Probably about 1/4 of an inch. I think it looks better now. I realize it's a bit silly, but what part of this project isn't silly? Okay, so the next piece is going to be the handguard. Now, if you're familiar with Berserk or with this sword, you'll know that there's a half moon guard on this thing. It kind of looks like that. You know what? If I'm really smart, when I edit this video, I'll put up a picture of it on the screen. Amazing. So my goal here is to make it out of this thing. I had the local steel supply shop cut me a slice of 1-inch plate. They just plasma cut it in a nice circle. It is oversized, as you can see. It's sticking off the edges here a little bit. Not very much, actually. Yeah, good enough. Basically, I'm going to machine this perfectly round. I'm going to put the groove in it as well, and then I'm going to chop the thing perfectly in half, and then I'll use each half for each side of the sword, so that they will be perfectly symmetrical. Now, in the manga, the half moon guard basically stops right at the edge of the bevel on both sides. And that's why I had to sand these bevels before I did this part, so I know exactly how wide the center strip is, and then I can determine what the diameter of this thing should be. We're actually pretty close, because we're right there, here, and I mean, I don't know if you can really see that, but we're not more than maybe an 1/8 of an inch off on that side. So I'll do some careful measuring and then we'll head over to the milling machine. I'm actually going to use this guy again. I have finally gotten it working. In the earlier parts of the video, this machine had broken down. It had a major mechanical problem, and then when I took it apart, I discovered 2 more major mechanical problems. When I finally got it all back together after months, I powered the machine on and it ran for like 10 seconds, and then there was a loud pop, and the machine has never run since. As far as I can tell, the machine was hack job wired. If you look down there on that plate, there was a huge electrical box of all sorts of like homemade electronics, some variable frequency drives and some controllers and everything, and like dozens and dozens of wires. It was this huge nightmare, and I couldn't get a hold of the previous owner to see, you know, what on earth he had done, so I just ripped it all off and I started from scratch. So I've got a magnetic starter for the main motor, I've got a variable frequency drive for the motor up there, and I've just got some kind of like hack job controls up here. This is like the previous guy's work, but I removed some of the buttons, I rewired some of them, I added my own. You can see there's a million wires in there. I basically just kind of left everything there. I repurposed some of the wires for my own stuff, and I just left the rest of it alone. I just wanted to get this machine up and running as fast as possible. I'm running into a deadline problem, so I just need to get this thing working for now. I got to get this vertical head aligned up so it's nice and straight up and down, left to right and everything. I'm going to put a rotary table on the machine to do all the milling, and we'll see how it goes. I have not even tested this machine since I got it rewired, so fingers crossed. Jesus. Yeah. God, how damn heavy that thing is. Okay, we are making some progress here. I've got my rotary table set up here. I've got a clamp down. I've got my workpiece. What I'm going to do is, to mill the outside of this, I'm just going to remove one clamp at a time. You know, mill this section, replace the clamp, take that one off, mill this section, you know, so on and so forth. So there will always be 3 clamps holding it down. I figured this is the easiest way to do this. Ideally, you would do this in a lathe, I suppose, but my little lathe cannot hold a piece this big, and my big lathe is it's over there holding up that fan. It's not even powered yet. I've never even run it before, so still a lot of work to do on that thing. Honestly, it would still be complicated because the truck would be holding it from the outside, so I'd have to like hold it from like the bottom, you know, and then turn half of it and then flip it around in the jaws, I guess, and try to make it perfect, which would be just a gigantic pain. You know, I guess not really any more or less of a pain than constantly swapping out these clamps, but anyway, if you've never seen one of these, all you do is turn that handle and it rotates the table in a predictable manner. There's all kinds of markings on here. You can do, you know, different degree increments and so forth. I have my ingenious powered setup here, you know. You get the idea. Now, half the trouble with these tables is trying to dial in this workpiece so that it's actually centered. And the problem is, this is not round. It's not even slightly round. So what I've done is I've set up my little laser here, and I kind of got it close to the edge, and then I just, you know, rotated the piece full revolution, and then saw where it was kind of off, and just, you know, tapped it a little bit one way or the other, because there's no real way of measuring it easily because the edge is so rough. And because it is so out of round, it's just kind of like the edge of it goes in and out constantly. So here, I'll turn off the light and I'll just show you what I mean real quick. All right, I don't know how visible this is gonna be on camera, but the laser is like right there. Now if I rotate it, as you can see, it's not perfect, but I think I'm close enough. This wouldn't be such a big deal, except the diameter of this is actually very close to what I need. It's about 200 thousandths of an inch off. That's only 5 millimeters. So I need to take off, you know, less than 1/8 of an inch off the radius, basically. That's not much. That's actually pretty close to what that gap is. So hopefully this works out. I guess I should have ordered a larger piece of material, but too late now. All right, well, I have no idea how this is gonna go. Wish me luck. The nice thing is I'm actually standing on the other side of the cutter here, and I can't really see what I'm doing, but I can use the camera's viewfinder to see what's happening. That's pretty nice. Alright, so I've made one revolution. It looks pretty good. The only problem is when I was measuring it, it seems like the sides of this are not perpendicular to the surface. The far end is touching down there, but there's a gap here. That's a pretty decent gap. At first I thought maybe the table itself, the rotary table, was kind of like kicked up at an angle. You know, there was something under one end of it that was causing it to, you know, just be angled slightly, but I have ruled that out. I thought maybe the milling machine table underneath the rotary table was sagging or something. I mean, I did have the machine completely apart for like months at a time, so maybe I misadjusted something, but everything seems fine. So I'm guessing the head is tilted this way. So for giggles, I checked the protractor on the side of the machine here. This controls the head, you know, tilt side to side. I don't know if you can really see, this is really old. It's hard to see in the viewfinder, but the 0 on the left and the 0 on the right, they're very close. I'd say that's off by maybe 1/4 of a degree. Honestly, that's fairly typical. You know, you usually just use the protractor to get close, and then you would use some sort of precise measuring instrument to actually dial in everything perfectly. I'm not really sure. I guess I'm just gonna have to strip down this whole entire setup that I just did and loosen up all the bolts and re-measure everything. Maybe I made a mistake. Maybe the head got knocked out of alignment once I started milling. Maybe it was kind of like bound up. You know, I had the bolts really tight, but everything was bound up, and then when I started milling it just shifted, you know, a degree or 3. I'm not really sure, but I'll see you in a few hours. All right, so I decided to do a little sanity checking here. I have this digital level, not the world's most accurate thing, but it's pretty close, honestly. I would trust it within 1/10 of a degree. So if I zero this out on the table, okay, and then I'll take it over here. It's still 0, so I know the rotary table is level. Let's stick this over here. The workpiece is level. And now if I take it, end mills are usually pretty decently perfect. And you can see it should be 90 degrees, off by almost 1 degree. Even if I put it on this cap is machined, it's not perfect, but it's showing. How about the spindle itself? Hard to say. It's actually much closer that way, but I think the outside of this is probably not the world's most accurate thing. I don't know, very strange. I guess I'm gonna tear this down. All right, so I figured out the issue with the head being out of alignment here, and honestly, I feel really stupid and really surprised that this hasn't happened to me before. I'll do my best to explain here. So this little tool basically accurately shows me how close the head is in alignment. each of these two indicators should be equal. They should give the same reading if the head is perfectly aligned, right? You know, the plunger is depressed the same amount on both sides, therefore the head is perfectly level. Now these indicators are in graduations of 1/1000th of an inch, so this is a quite accurate setup. Now I've already fixed this side. You can see this one's showing about 3/1000ths. That one is showing 3/1000ths as well. That's actually almost perfect. If I can get it, yeah, like that. Normally you'd be testing right against the table itself. You don't want to introduce more error with one of these. Problem is this table is 84 years old and it has, you know, multiple lifetimes of pockmarks and abuse on it. So I use this ring to kind of even everything out and give me a nice flat surface to, you know, measure against. And you can see it is quite flat. If I move this around, those indicators really don't move, so I'm not getting any sort of deviation at all. Now, as mentioned, I've already fixed this, so it's difficult to show you what I did, but I also discovered that the head is off going in and out for exactly the same reason, so I'll demonstrate right now. Turn this guy 90 degrees, so we're perpendicular to the table. Okay, so left side we've got, what's that, about 49, just under 49. And the other one we're showing, that's just about 48, just over 48. So pretty close, less than 1/1000th of an inch between that side and that side. That's not terrible. But the head is out of alignment still, so how did that happen? The answer is, if you look closely at these stems and how much they are extended, the right side is extended further than the left. It may not be that obvious on camera. It's really not obvious in person either, to be clear. What has happened here is a full sweep of one of these gauges is only 0.1 inches. And that's what's happened, is one of these is sticking out 0.1 inches more than the other. So they actually ended up on the same reading, but one is off by a full revolution. It was really only noticeable when I was doing it the other way, and I had these plungers depressed all the way, and so the difference was immediately apparent, and I realized what I had screwed up. Furthermore, as I turn it, if I watch the gauges, they are actually rotating the opposite direction, and they both end up at the same place again, but they went the other way from each other to get there. That's so now, this is actually how it's supposed to be. It was off by a full revolution when I had it the other way, perpendicular to how it is now. So, yeah, it took me a little while to catch that, but I can't believe I made the mistake twice in two different directions for the first time ever, if that makes any sense. What's also interesting here is if you look at the protractor on the side of the head, we've got our 0 here, and before we were off in the other direction, and now we're off going up, I guess. It actually looks like it's 1 degree off, but it is actually perfect now. Before it was closer, so I thought it was fine, but it turned out I was wrong. And if we come around to the front of the machine here, again, I don't know how well you can see this, we got 0 here, and then the 0 on the head is actually down below by over 1 degree. It's about 1.5 degrees off. So again, it's in the ballpark. It wasn't immediately obvious that was a problem, but I believe the head needs to come out towards us, you know, enough to make one, one revolution of the dials and get them, squared away more or less. I'll show you in a second what I mean. All right, I got this realigned. Let's see where we are now. We got just under 2, I would say. And just under 2 here. That's basically perfect. And now when I rotate it, hey, look at that, the gauges aren't moving at all. The way it should be. So what do I got here now? I've got a little over 1 and just under 2. So we're off very slightly. That's less than 1/1000th of an inch of deviation. I'm calling that good just based on the fact that this table is definitely not even close to perfect in the first place. And I'm introducing extra error with this thing, so chasing perfection is just it's kind of pointless and ridiculous at this point. And furthermore, what happens is when you align it in one direction, it kind of tends to throw off the other one, and then when you fix the other one, it throws off the first one slightly. Even the order of torquing these nuts has to be correct, or it can throw it off as you're tightening it. So it's such a delicate operation. I'm calling, perfect in one direction and less than 1/1000th of an inch in deviation the other way is good enough. All right, let's tear down this whole setup and get the rotary table back in there, get everything dialed back in, and let's get back to milling the thing. All right, so we've just made one revolution. I basically trued the whole thing up. This is the second to last cut, as we are actually only 43/1000th of an inch oversized at this point. That's just over 1 millimeter, so one more pass and we're there. I did, however, want to make sure that we're cutting straight. So let's see, I'm trying to line up the camera here. I think you can see that. Yeah, that is nice and straight now. Thank God. All right, so we are on to the next step. I'm gonna make this groove. You can see I just kind of haphazardly marked it out here. It's gonna be 1 inch from the edge, just over 1/2 inch wide, and it's gonna be 1/2 inch deep. This should be much easier to do. I've moved the clamps out to the edge, so I don't have to keep, moving them around every time. I should be able to do continuous rotations, basically. Probably gonna take like 4 passes. I'll do half depth, then full depth, then I'll kind of like kiss one side and then kiss the other side to just clean it up, make it a nice surface finish, and hopefully it'll be minimal cleanup when I'm done. Alright, we've got the slot roughed out to full depth. You can actually see the 2 steps in there, the 1/4 inch for each step. And you can see how rough this is. I don't know if that makes any sense, but since I was removing so much material, I was hand feeding it just to kind of keep an eye on things. And you can almost see like every revolution that I did by hand. My goal now is just to remove a small amount of material from the inside and the outside, and I'll do it with my homemade power feed. Hopefully this works out and gives me a nice smooth finish, and I won't have to spend a million years hand sanding it out. Alright, that's that for the machining. You can see the surface finish on the walls is absolutely dramatically better. I actually went a little bit better on the outside. I really sped the machine up top speed to really try to get a good finish. So the outside is a little better than the inside, but it's not really super dramatic. Some light sandpaper, wire wheel, Scotch-Brite should clean that all up. Honestly, the floor is probably the worst part, but that is not terrible. It feels nice and smooth, so it'll be a minimal amount of work. Only thing to do now is to cut this thing down the center so I can put, half of it on one side, half of it on the other side. I just need to remove as little material as possible while splitting it, so I need to think on that just a little bit. Okay, here we are. We're finally gonna split this thing in half, but first, we need to put a nice groove right down the center of it. The idea here being I'm going to put the groove in it, then I'm going to cut it in half, and it will leave me with a perfect bevel even on both sides of the 2 halves of this handguard. Now the bevel is actually a design element that I nearly forgot about. If you look at any of the manga drawings, there is a substantial chamfer on the edge of the handguard. It's not so much a decorative thing as it is a functional thing. I found this out myself. The issue is when there's a handguard with a sort of a 90-degree edge on it, it digs into the edge of your hand when you're swinging the sword really, really, really badly. If you watch my last Smash video, I actually ended up with a double blister, like a blister with another blister under it once that blister popped. And it left a scar for about a year, like right about there on my thumb, where it was rubbing on the edge of the handguard. So it's kind of funny if you think about it. You know, it's a fantasy manga, sure, but they had the foresight to have a little bit of thought into that handguard, you know, how that would actually work. I assume so anyway, unless it's just a massive coincidence, but I doubt it, honestly. I can't really think of any other reason why there would be a chamfer, you know, where your hands go on the handguard. So, long story short, I have lined this piece up so that it is perfectly in line with the movement of the machine. I used my laser to do that earlier. The idea here is I'm going to use this little V-bit cutter. I don't know if you can really see it or the camera's blocking the light, but it's a 45-degree V cutter, and it'll cut a 45-degree V groove in this material. The idea here is I'm going to basically use the entire depth of this cutter, cut a nice groove in the material, and then I'm going to use that spindle over there with a slitting saw sticking out of it to then cut the piece in half, and I won't have to reorient this workpiece here. It'll still be perfectly aligned. May have to trim the tops off these studs. I'm not sure if it'll clear. I've already had to do quite a bit of finagling to get this to go here. I use these little tiny clamps so that they will clear on either side of the cutter as they come through, or rather that giant nut anyway. And I have just enough clearance here. I mean, that is really tight. Let me turn the machine on for a second here. You can see that just barely clears, but it's good enough. So one last note on this. This is a different V-bit cutter. It's actually the same dimension, just a different brand. The issue here is the surface speed on the outside of the cutter is going to be optimal, but the surface speed at the center is going to be almost nothing. There will be a huge disparity, right? Now this cutter is made from solid tungsten carbide, which is extremely strong but extremely brittle. So what is probably going to happen is the tip of this thing is going to break off, simply because, you know, the workpiece is getting fed into the cutter, and the cutter can only spin so fast, especially on this old girl. This is a 1938 machine, doesn't have a very high speed, so there's a possibility that I'm literally going to be pushing the workpiece into this thing, and it's just going to snap the center of it off because it can't cut fast enough. I guess that's the best way to explain it. To try to combat that, I am going to run this machine at its highest speed, and I'm also going to feed the workpiece into the cutter at the lowest possible speed. So low that this cut, it's a little over 8 inches or something like that. I think it's going to take 12 minutes. 12 minutes to make one pass, so it's gonna be pretty boring, but you know, what are you gonna do? Hopefully, if the cutter does break, it's just the very tip, just a little bit, and you know, I can go back after I split it in half and I can kind of finish the bevel. You know, if it's 90% complete, I can use it as a template to just kind of finish it by hand. It would be nice if I could make a perfect cut though, because then I could use the groove of the cut to line up the slitting saw later and make it, you know, relatively perfect, or at least easier to do. For the 3 actual machinists watching this, yes, I could have used a flat bottom cutter and then just tilted the head at a 45-degree angle so it made a perfect groove. Problem is trying to line it up, you know, line up that leading edge of the cutter when it's angled into this, you know, center line here. It just seemed more trouble than it was worth. And again, even if the tip of the cutter does break, I think I'll be okay as long as it doesn't break too much. And for that matter, this is a double-ended cutter, and I have another one as a backup, so hopefully eventually I'm able to make one complete pass here. But we'll see. Alright, I would say that was a success. That's the first time I've ever done this without breaking the tip off. If I zoom in a little, you look carefully, there's a little rub mark right there, right on the edge. It goes all the way around. And you'll see it's because you can kind of see there's a little step at the top of the cut, right up there. That's because I had to plunge the cutter deeper than it's rated for. I wanted a deeper bevel, and this was the biggest cutter I could find on a short notice, so I just kind of went a little too far, and I've got this little step that I'll just file out later on. But I really wanted this bevel to be a little deeper than the cutter could handle, so even that seemed to work out pretty well. I'll be able to touch that up by hand, and we've also removed a significant amount of material for that to cut through. It's maybe a third of the way, almost a third maybe. I've got this nice little groove right down the center where I will line up the saw, and I guess we'll see how that goes. Alright, so I'm utilizing the same setup as before. I took off these other clamps because there's just no clearance under that tool holder to do this. I'm not too concerned about it. This is still very tight to the table with these clamps, and I'm going to be cutting really slow, so I don't expect to be kicking this out of these clamps. Got my coolant set up over there. I've got this lined up basically as perfect as possible in the center of that groove, and I'm going to try to take this in 3 passes. I know a lot of people do this in 1 pass, but I only have 1 slitting saw this size. I've never used a slitting saw before, so I'd really like this to not explode. That would be great. Alright, so I ended up stopping the cut in the middle of its travel here. I don't know if it was noticeable, but the blade actually stopped spinning for like half a second during the cut, and that can be an extremely dangerous situation because if the blade stops spinning, but the table continues to move the workpiece, you know, through the material, it's going that way actually, it will shatter the blade. And that's true of basically any sort of milling operation. So I wanted to do a little investigation to see what the issue was. I'm honestly surprised it didn't shatter the blade. I guess it was just either so brief, or my current theory is that the table also stopped feeding at the same time the blade stopped moving, which tells me there's an issue with the drive system. So if I come back here, I think I've actually found the problem. Now, I've taken the old belts off here, but you can see there's pulleys for 5 belts. When I came back here, I discovered that there were only 4 belts, which I knew about, but I figured 4 was okay for now. However, one of the belts was completely slack. It was this one, and you can see how there's like this polished surface on that pulley because the belt has just been slipping. So I was actually down 2 belts. The remaining 3 seemed pretty worn, and they were somewhat loose. Not badly, but considering I was down 2 belts and I had 3 kind of slack belts, I figure I was running at 50% or less power before, you know, I was getting slippage. I assume that's what happened because if the table stopped feeding, that means just nothing was happening in the system because these belts were slipping. This is the actual motor down here. The motor wasn't transferring power to anything in the machine. That's my theory anyway, but long story short, I'm going to replace all 5 belts right now. I raided 4 of the local auto parts store and just got some belts. Technically, these are not the correct belts, or rather, they're the correct part number. There's a pile of them down there, but these are really more for like automotive applications. And for this, where I have 5 belts, they really need to be precisely matched, right? Because one can't be slightly longer or shorter than the others, or you're gonna have a tensioning problem. I'm gonna throw these belts on for now just to solve my problem, but I'll have to look into getting a match set later on, which is ungodly expensive, but what are you gonna do? All right, that was simple enough. I ended up adding quite a bit of tension as well. I've kind of got these inside ones a bit overly tensioned, and then this outside one and this one are somewhat loose. These are probably right where they should be, and these other 3 are slightly too tight. I kind of want it too tight because I figured the tight ones will stretch or wear, and then the loose ones will be, you know, just right. Otherwise, if I have it a little bit loose, and the loose ones are just going to be slipping, and I'm going to have the same problem. Worst case scenario, these just wear out really fast. But I need to order a match set anyway, so I guess I don't really care. These aren't so tight that I think they're really gonna put, you know, significant wear on the bearings and such. Obviously, these are massively huge structures, and they should be able to handle quite a bit of load. I mean, look at the size of this motor. I don't know if you can see compared to my hand here, but it's like a 250-pound motor at least, I would say. I think it'll be fine. That thing's been running for 84 years, so I think they built it pretty well. Alright, I think I've identified the issue here. If you're not familiar with, any kind of arbor or large end mill or whatever, they've got a shaft that goes in there and it's got two flat surfaces on it, just like this. This is actually the tool I took out of there originally. And you stick the set screws in the holes, you tighten them down on the flats, and then it prevents this thing from rotating. And when I look in there, those are not flat surfaces. That's just, that's part of the shaft. So I must have tightened the set screws down on the wrong point, or they loosened up, which let this rotate. So not a catastrophic problem, but now I just gotta get this thing out of here, which may be more difficult than it sounds, because if it's been spinning in there, it might have a burr built up, and it's a very, very, very tight fit to begin with, so this should be exciting. Okay, got it out of there, not too much trouble. Interestingly enough, I don't see any scratches where the thing was rotating against those set screws, so I guess the set screws just loosened up? Or maybe I didn't tighten them in the first place? It doesn't really seem likely. I'm usually kind of overly enthusiastic about things like that, so I'm not really sure. Actually, I wonder, do those flats even line up with those holes? Is that what the whole problem is? Stand by. Okay, I've discovered what may be the problem, and that is, you can see the flats in there now. They're nice and lined up perfectly, but there's a little gap right here. I think before I had this arbor all the way in, and the flat surfaces were a little bit too far that way, and the set screws were just kind of right on the edge, I guess. Kind of like this, where this raised section is, where the bevel is. If the set screw is off center, you can see it's a very precise fit, so if it's slightly off center, it's not going to seat right. It would have been like that or something like that. Can't really see if on the viewfinder if you can see what I'm talking about, but I think it was just catching the edge just like that. So I'm gonna line it up a little bit better. I'm gonna crank the hell out of these things, and what are we on, like round 3? Just trying to make it, we're not even halfway through this cut yet, so. Yeah, so I've got it all back together now. I really cranked down those screws, and you can see the arbor sits in a different spot now because the saw blade is not quite centered on that slot. So I'm gonna have to readjust my cut and give it a go. Well, that's that, I guess. So I backed the blade out of the cut, and I basically recut the section I already cut, assuming that the blade wasn't perfectly centered on my old cut. I did my best, but it was probably not 100% perfect, right? And a few seconds after it hit the part where it had last failed, it failed again. And that's it for this blade. I don't know if you can see this. Yeah. Nice crack appeared right there. I don't know why it would have stopped. I guess the only thing I can think of is maybe I should have cut deeper to redo that cut, because it had the blade had stopped in the cut last time, so maybe there was a little impression, where one of these teeth had kind of stuck in the material and then jammed up. So when it got to that point again, it just jammed again. I guess that's all there is to it. That's what? 4 days of work wasted, because I'm just gonna go over to the bandsaw and cut this stupid thing in half. At least I have a really nice line to follow now. This should be easy to do, but sheesh. So small update, I started disassembling this cutter. I don't know if you can see this, but the key is actually sheared off, or at least partially. This thing is jammed on here pretty good. Oh, I guess that's that. Let's see if I can hammer this thing off. Yikes. Yep, check that out. Hot the key sheared right off. That's something. So that blade got really jammed up in there. I don't really know how or why. I mean, even with that previous cut existing, I was basically running the machine as slow as possible. It actually is the slowest feed rate possible. And the minimum, very minimum recommended RPM for this blade. So I couldn't have been more careful, but I don't know. Alright, one last note on this stupid blade before I throw it in the trash. I did notice this. You can actually see some wear marks on the edge here. It looks like the blade was rubbing on this side. It's only on that one portion of the blade and it's not on the other side. So maybe the blade got warped or bent when it jammed up the first time, and then when I tried to put it in the same cut, it just kind of bound up. That had to have been it, I guess. I don't know. I've been wrong every single time, so who knows. So as anyone who has ever watched this channel knows, when I say I'm giving up, I am not giving up. So I figured I've already broken about $100 worth of tools. Let's go for 200. So I've got a smaller slitting saw on here with a smaller tool holder. So I have clearance still under there when it passes over. And I figured I'd give this a shot because this is a side cutting slitting saw. Basically both sides of it look like this. It can actually cut, you know, not just on the tooth, but on the edge. So it's much harder to bind it up, or at least, you know, theoretically. I'm also going full depth on this cut. I'm going to go all the way through, all the way to the other side, trying to like get under that section that might have some sort of burr on it that catches the blade. Who knows? I figure it's also less likely to bind up if I'm going full depth because the chips can fall at the bottom instead of kind of compacting in that slot. That may have been what caused the initial problem. I'm not really sure. I have a million theories and probably none of them are right, so let's go break some more tools before I finally break down and just bandsaw this thing. Well, I can scarcely believe it myself, but I think it worked. I stopped the cut because I could see the pieces getting wider at the end, which tells me it is cut. Yep, look at that. It's just held on by a little bit at the end. I'll clean that up. I just didn't want the cutter, once it actually cleanly cuts through, I didn't want it to grab the piece and kind of like eject it. That would be crappy. So I'll just do this a little bit. Wow. Absolutely amazing. Alright, so why did that work when the previous attempts failed? The real answer is I actually have no idea. I mean, I tried so many different things, I changed so many parameters, and it didn't really seem to matter that much until the very end. Theoretically, everything seemed fine, but obviously the cut was just jamming up and breaking the tools and so forth. So spinning it faster meant less of material is being removed by each tooth as it comes around, and you know, it creates this kind of slurry. It's much finer chips, and it's not really optimal, but I guess it worked. Theoretically speaking, I guess I was wearing out the cutter faster, but you know what really wears out cutters is when they break in half. So long story short, I don't know, maybe I should have started with a full depth cut to begin with, but I figured if anything that was putting more strain on the cutter. Conversely, it worked better. I don't know. I guess I'll chalk it up to a learning experience. Alright, we've got this thing cleaned up a little bit just to see how it looks, and I would say it's not too bad. There's one defect right there. This is from the first time I had the saw blade kind of spin in the holder because of those set screws. And then when I went to put the blade back in the slot, it was slightly misaligned, so it just nicked the edge of this before I realized what was happening. But I'm not too concerned because both pieces are going to get welded to the blade, and then I'm going to kind of machine the end of the blade, you know, flush after the welding, and it's going to clean up that little error there. Let's stand these up and see if they actually got cut in half. Alright, so was it all worth it? Whew. That is pretty close if you ask me. Let me stick a ruler on that. I don't see any light coming from one side or the other. No gaps at all. I'd say that split it just about perfect. Unbelievable. The surface finish on the cut is absolutely terrible, but you know, I don't know what could really be expected of stopping and starting, I don't know, 10 times or something like that. You can see all these gouges. This is probably where it got hung up, you know, at one point. It was about a 1/4 inch deep, so that's probably one of them right there. Probably another one right here. This was probably a second pass where it got cut up, etc., etc. So, not a big deal. Again, this surface, this bottom edge, is going to get welded to the blade, and then the whole thing is going to get milled flat to eliminate the weld. So I'll take a little tiny extra bit off just to clean up all this, and it should look pretty good. Speaking of, let's just go stick this on the sword and see how it looks. It'd be funny if I just like totally mismeasured this or something, but yep, that is pretty nice. Now, if you have really eagle eyes, you may notice that the semicircle is actually a little bit too big. It's protruding past the flat section of the sword. But the reason is, if you look at the Dragonslayer, the handguard hangs off the end of the blade by maybe 1/2 inch. So what I've done is I've actually made the blade 1/2 inch too long. And this little blue mark indicates the material that I'm going to remove. I'm actually going to mill this much of the blade off, and the blade's going to end there. So what I need is the intersection of this, the flat part, and the bevel all right at that blue point, and I mean, can't get much closer than that. Alright, just a really quick mock-up here, just to do both sides and see how it looks. That is a thick boy. It is a full 4 inches thick. That is absolutely incredible. Never made a sword even a fraction of that size. I feel like the guard is really tall, but when I compared it to some reference pictures, it looks about right. It's just incredibly bulky, I guess. Phew. Looks pretty close to perfect to me. Okay, so it is now the next day. I took a bunch of pictures of the sword blade mocked up with the handguard pieces. I thought it looked good last night, but after staring at the pictures for, 3 or 4 hours, I think these things are a little too chunky. Kind of looked at, 20 or 30 or 100 reference photos, and it's pretty chunky. The manga version is pretty chunky, but these are just a little bit too much, and not a big deal. I intentionally made these pretty thick because I figured I can always just mill them down if they're too big. But it's much more difficult to make them larger if they were too small. So, long story short, I'm going to deck the top. I'm just going to take a little bit off, 20,000ths of an inch. That's 1/2 millimeter. The issue is there's some defects. You can actually see little pinholes and stuff like that. This is, as received from the steel mill, so it has some surface problems. So I might as well, while I have the machine set up, I'm going to deck the top, I'm going to flip it over, and then I'm going to take a 1/4 inch off the bottom, making the 3/4 of an inch tall instead of an inch tall. I'm gonna take some more pictures, mock it up again, etc., etc., and we'll see how that looks. I think we'll be pretty damn close. Alright, one last note here. I'm gonna be running this face mill at the machine's maximum RPM. The idea here is to create the best possible surface finish. I'm also gonna be feeding it slowly so that it can, clean up as it goes, so to speak. I also swapped out all these carbide teeth here with brand new ones, and for the 3 machinists watching, these are ISCAR 928 grade, which is the best I've found for, mild steels, basically. I would appreciate any comments from actual professionals on what they might use for this kind of insert. These are APKT 1604 size. Alright, let's get to it. Alright, well, you know what? That turned out a lot better than before. Pretty nice. What's especially interesting to me is that, I ran the cutter at the same speed the whole time, everything was exactly the same. You can see some scratches here. And then down here, the exact same part, there are no scratches. That is like a nearly perfect finish. This material is fairly gummy and it's never gonna have like a real mirror finish, but this is pretty good. You can see how it kind of smears a bit, if that makes any sense. It doesn't really cut cleanly, but that'll clean up very nicely with some sandpaper. I suspect there is wear in the table, you know, more at one end than the other. So as it's traversing, you know, you're going from a worn out part to a less worn part. If you think about it, it kind of makes sense. You know, usually the vise is in the middle of the table. Most of the work is done kind of in the middle of this machine's articulation range. But when I was cutting this, you know, I started with it in the middle of the table. You can see here's the stop over here, here's the stop over here, where we're like directly in the middle. But by the time the cut reached the end, the table was a lot that way, and we were actually almost out of travel. This stop over here was just about to reach this knob, which would automatically shut off the machine. So the table was actually in a very unused portion of its travel, right at the very end. So I guess that's why the very end of this looked pretty clean, and then the rest of it has some scratches in it. The table was, you know, shaking very, very minutely due to the wear in it. Only real way around this is to like regrind the table and then hand fit it back together and everything, which would take thousands of dollars and probably months of work. So I think I can deal with some scratchy finishes that I'm gonna hand sand out anyway. So good enough for now. It's just fascinating to see the literal progression. You can see the scratches start right about there. They almost get heavier and heavier. The heaviest right there, you can kind of see they almost look fairly deep right there. I mean, I can't even feel them at all. My fingernail doesn't catch them either, so they're very shallow, which means they will clean up very nicely. It's all just a little bit of interesting trial and error, I guess. All right, this is the second one. How does that look? Better, worse? I think it actually looks very slightly better. You can still see the scratches, but they're just not quite as prominent. Let me put them side by side. All right, so this is the first one I did, and this is the second one. In between passes, I very slightly tightened the table, maybe 3/4 of a turn of the bolt. And it's to the point where it takes two hands to actually move the table at the end of its travel. But I was curious what the difference is. I didn't get a good angle. Quite a few scratches there, especially on the right side. That is definitely better. Especially right here, look at this section. You can see there's some scratches in there. Especially I hold the camera like that, you can see a few scratches here and there. And then look at this. Look how many scratches there are. That's fascinating. Even weirder, here's the first one again. Right at the top and bottom of the cut, at the very limit of the cutter, there's kind of this like smudgy area. I don't know if you can really see that. It's like a straight line, and it's at the bottom too. Yeah, you can just see this little smudgy area right at the bottom. But after I tighten the table, it's actually worse. It's a slightly bigger. You can see up here, that little spot right at the top of the line there. That's interesting. All in all, it doesn't really matter. They're both gonna get hand sanded and they're both really close. It's just interesting to see the results of slight tweaks to the machine. All right, let's flip these guys over and then cut almost 1/4 inch off the bottom. Probably take it in 3 passes, I would say. Should be good. I've got 1/4 inch decked off the first piece, and I just wanted to mention it was really close to hitting the jaws. I had measured it ahead of time and I knew I had the clearance, but Still a little bit of a butt pucker moment, that's for sure. All right, that is significantly better in my opinion. Even just sitting on the table right there, you can just see that this one looks just about right. Might be slightly too thick, but I think I'm gonna leave it at this point. Part of the reason is, on the back side, I have to weld to the back of the sword, and these slots are so deep that I do not have a huge amount of room here. I'm gonna have to bevel this and then weld into it. So I need a little bit of meat there, or I'm gonna run into problems. So I'm calling this good enough. Just gotta finish this one up, and then let's do a real mock-up. All right, mock-up round 2. I think that is much, much better now. Still nice and chunky, but doesn't look quite out of proportion. It's interesting in checking all the source materials to try to see if this looked all right. You basically can't find any views from this angle. Almost all the views are like from the side, like that, or they're like that, or something like that. You might get, you know, at best when the sword is on Guts' back, it's kind of like that. But really, you never really see the sword from that angle. It's usually from down here, and you can't really tell how thick it is, so it was difficult to really determine it until I found a few good shots. And I'd say we did really, really, really well. Okay, so the plan is to attach the handguard. It's gonna get welded here. I'm gonna bevel this gap so that I've got a spot to weld into. But it's also going to get clamped together. There is the chain link that's in the center here, where Guts, you know, carries the sword on his back, and I'm just going to use an eye bolt that goes all the way through the sword and clamps the two pieces together. So what I'm going to do is just drill a hole all the way through the whole thing, you know, with everything kind of clamped together, so that I have a perfectly straight hole through everything. Now, normally I would do this on a drill press or the mill, but I've got to drag this gigantic thing to another room in the shop, and just to do like a, you know, 60-second drilling operation. So it's going to take me 10 times as long to get this thing over there and back. So what I'm going to do is use this thing. This is a mag drill. It's basically just a magnetic drill press. It's got this huge magnet here. You can clamp it to any, you know, steel surface. And then you can just use it like any drill press, basically. Given that the sword is so thick, it's got plenty of meat that the magnet can, you know, have full force, and it won't pop off there. Should be able to make that hole in just a few minutes, save me a whole bunch of hassle and possibly dropping the sword on my foot, you know. I generally rather avoid that. Of course, the only downside to using these things is they're extremely heavy. Alright, we are all set up and ready to go. The moment of truth. I basically just lined it up by making sure the drill doesn't deflect when I, you know, just kind of slide it in here like this. I've got to drill almost 3 inches. I think the sketchiest part is going to be when it gets to the bottom plate. That's why I have all these clamps on here. If the bottom plate starts moving around, it's going to be a real problem. I'm going to go pretty slow here. Lots of cutting fluid. Hopefully this works out. Alright, that went surprisingly smoothly. The biggest issue was just the amount of time it took, because once I got pretty deep with that hole, we were buried like up to here, and the chips weren't really able to evacuate, so I just had to drill a tiny bit, clear all the chips, tiny bit, so on and so forth. But looks like we made it. It is not too bad. It looks pretty centered. Let me take that apart and see how close we came to actually getting that through hole like perfectly straight. I've always really wondered how accurate one of these drills are. All right, moment of truth. Let's see how well these holes lined up here. You know what? It's not perfect. That's pretty good. You can see the misalignment on the right side there. It's just not quite perfect. Not too bad for a 3-inch deep hole with a mag drill. And not only that, but I stupidly picked out the wrong drill bit. You can see it's all chipped up. This is an old one. It wasn't even sharp. The problem with that situation is that if one side is cutting better than the other side, the drill bit will kind of want to wander, you know, slowly over the course of the cut. All in all, I would say that's pretty good, and it's plenty good for what we're doing. The only thing this is doing is holding that eyelet on for the chain link, and it's going to come out the other side and be welded on. So the hole location was not critical. I was just curious how well it would actually do. All right, so while you weren't looking, I was over at the mill and I just did a counter bore on this underside half guard piece. The idea being, when I bolt it all together, I want to, you know, put a nut on the end. It's going to sit below the surface, and then I'll fill this hole back in with weld, grind it flat, and then you'll never see the fact that it's actually bolted together. That's the idea anyway. You know, I'm sitting here trying to come up with the perfect way to sand inside this groove. You know, I just got random things to kind of fit down there, all kinds of stuff like that. Even this marker is pretty close. And then I realized that I'm a complete idiot because my finger fits perfectly. And this way I can sand the side walls and the bottom at the same time. Who would have guessed? I'll only be in pain for like a week after this, but you know, what are you gonna do? Okay, a second thought, it's been, I don't know, 2 hours, and I don't know how well you can see this, but I've barely made any progress. It does look better, but you can see those circular milling marks everywhere, and my hands are absolutely killing me. The only advantage is the outside walls actually look pretty good, but this is just gonna never happen, basically, especially since I have another whole one to do. Excuse me, I'm trying to film. Thank you. So this thing is a magnetic chuck. You just turn it on and off with this handle. It's used for machining operations and such. Really handy for this sort of thing, because when I had a clamp on the edges or whatever, it would interfere with my hands as they went by, and it made it repositioning a nightmare. So anyway, mag chuck really works really well. I think I'm done with the groove. Not sure how visible this is. The light in here really allows you to see every tiny little flaw. I can see a little bit, but this is literally day 3 of just hand sanding this one groove on this one side, and my hands hurt a lot. So I think I'm calling this good. The walls got sanded pretty well as well. Again, not sure how well you can see that. I'm just looking through the viewfinder here, but I would say it's pretty good. Feels very smooth. Okay, so off camera, I hand sanded the bottom piece here. I don't know if you can really see it, but it's good to go. And I also sanded a bevel on both the blade and the handguard half. So basically the idea here is this groove will be welded into probably 2 passes, just to deposit a sufficient amount of material. And then once that's all done, I'll bring this whole thing over to the milling machine again, and I'll face off this entire surface so it's all, you know, uniform basically. And that should show me any sort of defects or anything like that. But I guess we'll see when we get there. What I've got to do now is I've actually got to black oxide the other side of this blade. I had only done this as a test originally, but I decided it's a good idea because trying to black oxide the blade after this has been assembled and getting this area is going to be tough. I am probably going to get some of the black oxide on this surface, and then trying to sand this surface without affecting this surface gets much more difficult. So I figured I would just, you know, kind of prepare it. I'll at least black oxide, you know, this section on the other side. But I figure I might as well just do the whole thing while I'm at it. This has actually held up really well. I expected it to get, you know, scratched and destroyed along the way, but I've been really careful and I don't see any real defects. So I guess we'll just flip this thing over. We'll black oxide the entire other side, and then we're gonna start welding. I can't believe we're finally getting to that stage. All right, off camera, I black oxided the underside of this. It was a huge nightmare. It took 6 tries and it still didn't come out that great, but anyway, I'm over it. I've got this whole thing protected with a big welding blanket, and if you look, you see how it's shiny. That's an anti-spatter spray. I really don't want some spatter getting, especially in these slots or something like that. It'd be such a pain to resand everything, but seem to be all set. I've got the pieces aligned top to bottom and, you know, front to back and everything. I think we're ready to go. Alright, that wasn't too bad. Some of the worst welds I've ever done, but what are you going to do? I don't think I screwed it up too badly, at least. Actually, I shouldn't say that. The reason why the weld on the bottom is much thicker is because I did screw it up. I was actually slightly off-center on the weld, so I had to do another pass just above the first pass, just to kind of fill it in. I had the shade on the welding helmet a little too high, and I just was a little bit off track. It happens. You can see how much taller that bottom weld is than the top weld, but it doesn't matter. It's all getting machined off anyway. All I have to do now is flip this thing over and then weld the underside of this eyelet, or eye bolt, I guess. Alright, as you can see, we got a bunch of spatter in there. Let's see if that spray worked. Oh yeah. That is very handy. I know you can just use acetylene, soot, or whatever, but a can is not much money, so what the hell, I don't have to drag out the whole torch rig. Alright, I'm going to let that cool a bit, and I'm going to go prepare the mill to mill off all this material here. I'll probably do this part by hand, maybe. Or I might partially mill it off. I'm not really sure, actually. We'll see. Alright, so I laid down some painter's tape on the mill table here just to try to keep from scratching the sword, as I'll have to shift it very slightly to line it up perfectly with that spindle. However, the first thing is The sword is over there under that welding blanket, and I gotta get it out here. I have completely filled everything in this whole entire area with a million projects, so I'll see you in a few hours. Okay, 2 hours later, I've got this thing strapped to the mill, and it's all dialed in, so I've got a nice straight cut here. It was really tough because the blade is a little bit warped at this point from all the milling and welding and such. So, you know, getting this lined up, and then when you clamp it, it kind of shifts a little bit, so you have to kind of overcompensate for the warp. Anyway, it took forever, but here we are. I'm just gonna machine off the weld here, and then machine off the last ½ inch of the bevels on each side to sort of give it the impression that the handguard is hanging off in space, so to speak. Obviously have to continue these slots as well, so it's gonna be a fair amount of work. Oh yeah, I also have to make the hole and tap it for the handle, which is gonna be a challenge. The only problem with drilling this hole is I realize I haven't left enough room. You know, there's gonna have to be a drill chuck hanging out of the spindle here, and then a drill that's gonna be out like that far. But the machine is already almost as far that way as it can go, so I'm not sure what I can really do because I can't shift the piece too much further. I guess if I put the whole thing up on blocks, I can get, you know, clearance for the handguard, and I can move it over here, but that's going to be, you know, re-clamping, re-indicating everything back in. I'm still not sure if I'd even have enough room at that point because there's so much sword hanging off the end that it's going to be unbalanced and it could just topple off, which is going to make the whole clamping and dialing in process much more dangerous and sketchy. So I got some ideas. We'll see how it goes. Alright, so my goal here was to just skim the surface and get really close to, you know, flat. If you look over here, this is where the cutter basically stopped contacting this surface right about there. I don't know how easily you can tell that. You can see where the black oxide is worn off. So it wasn't touching here at all. So my piece is slightly misaligned, but if you look here, I mean, it is so close. It looks like a lot when you're looking at it from this direction, but I can barely feel that. It's probably, you know, 10,000ths of an inch. So I'm looking for weld defects. Doesn't look too bad, but I see a pinhole there and one there, for example. The bottom has quite a bit of undercut, but I think I'm gonna need another pass before I decide whether that needs repair or not. There's just a little bit too much material left over. You can see some right there too at the bottom of this. Maybe we'll take 15,000ths, 20,000ths. Alright, taking a second pass here really helped clear things up. It actually looks pretty good. It's funny how different the weld color is, and you can see these spots. These are where the tack welds were initially before I did the full welds. It's exact same material, exact same welding process, but somehow the tack weld is a different color than the rest of the weld. Looking closely here, I don't have much cleanup to do. This is actually really good in my opinion. I see some little pinholes, another one there. There's some touch-up to be done on the corners. I don't know how well you can see that, but there's almost a little crack, so to speak. It's more visible there. You can see that now. This is where I kind of tack welded the edges in, so it wasn't a perfect fusion. That one looks good. Up here, again, a tiny little bit, so maybe half a dozen things. I'll die grind those out. I'll TIG weld them in place, and then I'll make one more really slow final pass. And I guess we'll call that part good. Oh, and quick note about the color. It really stands out now, but when I'm all done with the machining and I hand sand this in with, you know, whatever, hand sandpaper, rotary, orbital, something like that, it'll kind of blend the color back in. I think it's less about color than it is almost like a slightly different, you know, reflection. It's slightly shinier versus, you know, duller. I'm actually colorblind, so I could be completely wrong, but you'll see later on it'll look a whole lot better. And in fact, I often can't even find my own welds after I have, you know, cleaned them up. All right, progress report. I have welded everything back up, and I made another pass, and I managed to fix most of the problems. You can see where the welds were. I think there was one there, one in this corner. They all look pretty good except that one, which is distinctly worse than it was before. And then that one, holy God, what the hell happened there? And long story short is I've actually ground these welds out and re-welded them 4 times so far, and I keep making it worse. So there's some sort of contamination. Probably on this one it's oil. There's probably a little bit of oil kind of seeped in the corner there, and I'm kind of just burning it out, I guess. This one, I'm not really sure. It is really weird. Like, it's a weld, but the edges of it are all funky, and there's something going on in the very center of it too. I keep grinding these out and re-welding these, and the end result is they get bigger because I'm grinding away more material every time. So technically I'm making this worse, but I assume at some point I'll get through the contamination and I'll fix it, or I'm gonna have some really weird looking giant holes in my sword. Not a good situation. Alright, round 3 or 4 or 6 or 20, but I've gotten this part all cleared up. You can see this is what it should look like. And then you come over here, and yeah, not really sure what to say. There's either a defect in the metal or something, because now I'm like way beyond where the original weld was, right? You can see the line. If I had some sort of impurity in there, it's one thing, but I'm up here and I'm still getting all kinds of fizzling and crap from the TIG welder. I'm now into this bevel up here, so that should be fun to fix. I'll give it one more shot, and then I don't know. I think I might even just hit it with the MIG welder. The MIG seems to care less about any sort of imperfections. I may be able to build that back up without too much problem. Alright, round 300,000 or so. We're about 6 hours into this, and I just keep making the problem worse, so we're gonna MIG it and hope for the best. Cross your fingers for me. Okay, got it all MIG'd up. Looks extremely ugly, but it really can't be helped. I had to kind of build it up in stages, so it kind of looks like Quado from Total Recall. Open your mind. Anyway, you can actually kind of see, I don't want to touch it, but that part that's protruding the most is where it was most, you know, screwed up, I guess. But the tacks on the outside look better. So I see lots of pinholes, some pinholes, I guess. Wait a minute, those aren't pinholes. It's actually just slag on the surface. Okay, let's just give it a milling pass real quick. I got 3 minutes, so cross your fingers again. Okay, well, not the result I was hoping for. You can see there's still lots of pinholes in there, but we have effectively reduced the affected area by a lot. I mean, you can clearly see where I just welded, and only maybe 20-25% of it is a problem. I'm gonna call it quits for tonight, but I'm gonna come back tomorrow, grind out this section right here, just this little bit, come back and MIG it again, and again, and again. And I think we might get there eventually. It's honestly crazy. I can only imagine that some oil or something got in there. I mean, I cleaned it so well before I actually started welding this, so I'd be really surprised. It is kind of interesting that it's like right below this welded spot. I don't know, maybe when I welded, the heat kind of pushed oil out, you know, toward the edges, and that's where it stayed, and that's why it's causing such a problem. But we're getting there. Everything else turned out pretty okay. You can see this corner repaired successfully, so we just have the one part. And I guess I'll try it tomorrow. Alright, it's now night number 2. You can see I have re-welded this a bit. I was actually able to confer with the master himself, Michael Cthulhu, and he had a tip that I didn't think of, and basically that was, you know, with the defective area so deep, I had to carve out so much material that he suggested, you know, doing some tack welds, just a few at the bottom, cleaning it thoroughly, you know, wire wheeling it, cleaning it up with acetone and so forth, then doing a few more tacks, build it up a little bit more, so on and so forth until you get some sort of hideous monstrosity like this. The idea being, I assume, to kind of clear out the contamination. You know, as you're welding, the contamination is kind of bubbling to the surface. In fact, you can generally see it. Now, you can't really see it here because I think it's actually gone. You would basically see this kind of film on the surface, this kind of like almost powdery substance that was brought to the surface by the intense heat. And I think by trying to like weld over that, it was just kind of recontaminating the weld. That's the idea anyway. I'm not even sure if that's true at all, but this welding went much better. The more welding I did, the less contamination I saw. So hopefully the surface when I, you know, mill this back will be clean. Same thing with over here in that corner and down there in that corner. You can actually see that, again, looks like a pretty decent weld. So I kind of lost count, but I think this is the 11th run around with grinding this out, re-welding it, re-machining it, on and on and on and on. It has been incredibly lengthy, I think about 7 hours, because to prep for the weld each time, I've got to cover every surface of the machine and everything nearby so I don't get spatter on it. I've got to spray the anti-spatter and everything. I got to clean the welds, you know, profusely, grind them out. I got to acetone them, on and on and on, trying to do this as perfect as possible. So every pass is actually a huge pain in the butt, but come on, baby. Alright, let's see how we did here. I don't see any pinholes. There's a little bit of a void right there. I think it actually got melted away from the weld. Not too worried about this because I'm going to take another full pass and kind of carve this down just a slight bit more. I think that'll disappear. How are we doing over here? Let me get the light on the subject here. That's pretty good. I don't really see any real defects in there. The edges, again, just a little bit, but I'm not too worried about that. Let's see this guy down there. More of the same. Looks pretty good. I'm going to take another, I don't know, 10 or 15 thousandths of an inch off of this surface here and try to clean it all up. I'm just hoping I don't reveal any more problems that are slightly deeper under the surface. That would be hilarious. Absolutely hilarious. Okay, update 379. We're looking pretty good here. This corner, nothing. That crack is gone. There's no defects whatsoever. Down here, this corner, nothing. Good to go. Up here, not gonna lie, still the tiniest bit. It's right there. You can see a few little wormholes, but we got rid of 95% of it. But the problem is, as I suspected, is we're going to start revealing other little tiny pinholes. We got a new one right there that wasn't there before. So this is it. I'm gonna grind out that little bit, weld it back up, one more pass, and then whatever happens, happens, because I'm just creating more problems for myself at this point. Plus, the more I mill off, the less semicircular this piece gets, the smaller this bevel gets, and so on and so forth. So I'm just kind of creating larger problems that I cannot realistically fix. So one more attempt to get these things squared away, and that's it, I swear. End of story. All right, my friends. Well, I think we did it. I don't see anything. Not a single speck. Did I get rid of this little mark over here? I can't even see where it was. I think we are good. Don't see anything new revealed. Okay, just a little bit of fluff. Okay. Yeah, that's it. I'm throwing in the towel. I'm going to bed. Check out my reflection. The welds are so much shinier than the base metal. That's kind of weird looking. Anyway, I'm a little loopy. It's getting late, and I would say we're about 9 hours into just fixing those little tiny pinholes. So I'm done. Throwing in the towel. Sayonara. Game over. Maybe tomorrow we'll get working on either these slots or milling away the edges here, or both. What a relief. I'm not gonna lie, that was incredibly stressful and incredibly frustrating, but I am extremely relieved to have that over and done with for now. You know, something that always kind of stands out to me is how rough things can look when you mill them. I mean, this looks ugly as can be, right? But it is actually perfectly smooth and perfectly flat, or about as close to it as you can get. It basically, I mean, it feels like glass. Perfectly smooth, no roughness or anything. It just looks really bad. So I'm thinking once I hand sand this a bit, it'll texture up and it'll kind of all match, hopefully anyway. All right, since we've got this big face mill installed, I'm just gonna use it to trim back the blade, the bevel portion, half inch on either side of the guard here, and then I'll change out the tool for something smaller to do the slots and other details and so forth. Oh, the tripod just fell and landed directly in the milling cutter. So, scratch one tripod. That could have been a lot worse. Luckily, I saved the camera. I just realized there's kind of a spot on the lens. I think a spark got it. Can't really see it in here. Can you see it in the light, maybe? Not really sure where it is. There it is. I see it now. I don't know how long that's been happening. Oh well, good thing I've got a whole stash of these things. This is pretty handy if you don't know about these. It says it's a UV protector, but it doesn't seem to affect the image at all, but it adds an extra layer of protection, and these things aren't like crazy expensive. I've actually ruined cameras from welding sparks and grinding sparks and such, so I always keep a stockpile on standby. Alright, new lens on, how's it look? Yeah, that's good. I don't see anything. You could see, might be able to see. I can't really tell in the viewfinder, but you can possibly see some spots on there. I actually see a few in person. Hopefully, you know, the entirety of the previous footage doesn't have this giant spot on the lens, but what are you gonna do? By the way, this is my tripod set up on the mill. You can see how it easily fell off and landed right on that cutter. It's just me, or that light looked very halo-y. Is this brand new lens dirty? Stand by. All right, how did that look now? On the viewfinder, it's much clearer. I guess the lens had quite a bit of haze on it right from the factory. My viewfinder is pretty beat up though, so it's kind of hard to tell. Maybe I need a new camera, who knows. Anyway, on with it. Okay, so we have gotten the majority of the milling done here. You can see we've got both slots here, and then we also milled away the blade on the edges. There's a lot of cleanup to be done, but we have a few more milling operations to do. Number one is we have to drill and tap a hole to mount the handle right in the center here, but there's also two circles, one on the other side of the handle. I'm not even sure what they're supposed to be. I'm not sure if it's ever explained in the manga. It may have been like two rods inserted to attach, you know, the guard to the blade, I guess. I'm not really sure, or that just could just be decorative elements, but regardless, we need to add them. Okay, we are ready to go here, drilling the hole for the handle. Now you'll notice I'm not using a drill chuck. I've actually got a collet chuck. See if you can see this in here. So the collets are hollow, which means I can choke up on this drill bit, which, you know, puts most of the drill bit back here in the spindle. I'll do the same thing when I'm making those little circles on the sides of the guard. You can kind of see how I had them laid out over there. This is what I'm going to use. I'll just stick it right in the collet. It's actually going to be a larger collet than this, but again, it'll give me just enough clearance. Only issue is going to be the tap, which is this guy, and you see it's pretty big. I'm gonna have to see how that goes, but we'll cross that bridge when we get there. One last note, I'm really hoping I don't screw up here because this is the only drill bit I have in this size, and also I've never drilled a hole this way. I'm actually gonna have to feed the table into the drill bit to make this work. Normally you'd have a machine with like a quill, like a drill press, where you'd pull down on an arm and it'll, you know, extend to drill the hole, but this machine does not have that capability. The only machine that I have that has that capability is way too lightweight to handle a sword this big and heavy. Furthermore, it's got a vertical spindle, so it points down, which means it's basically impossible. The sword is too tall. I'd have to raise the milling machine up by like 2 or 3 feet, which is just not happening. So here we go, fingers crossed. Alright, we got the hole drilled, we got it countersunk. It's time to put some threads in there. I'm gonna do this the stupid way, I guess. The goal here is I want to thread this hole perfectly straight, so when I thread the handle on, it's not crooked, right? Now, the best way I've come up to do this is to just loosely hold this tap in this collet chuck. I don't know if you can see, yeah, I can just turn it with my hands. And I'm gonna feed it into that hole until it catches and it starts spinning. Then I'm gonna stop and I'll use a pipe wrench, this big boy. I'll use it to manually turn the tap at least a couple turns, or maybe even all the way, I guess. Obviously this will damage the tap, but I have like 10 of these things and this is the cheapest, crappiest one, so I really don't care. by having it pretty tight in this collet, it's gonna keep it straight while I'm, pipe wrenching it into the hole. If it becomes a huge pain in the butt, I'll just stop once I'm a few threads deep, and I'll do it later when the whole thing's off the mill. But, once I have the thread started, then it'll continue straight. It's not gonna veer off later on when I do it manually. So fingers crossed this works and it doesn't cause some sort of catastrophic damage. I guess we're about to find out. Oh, a little side note. I just found something in this pile of chips. Am I missing something here? Check that out. I literally drilled the bolt in half without even thinking of it. You can see where it came through. It's right in the center line of the sword, of course. So that hole actually drilled right through the bottom of this bolt, or right at the middle of the bolt. All that work, and I just drilled it in half. So that means, I don't even know. What am I gonna do about that? I guess I'm gonna have to weld it into the bottom of the hole, I guess. Wow, I'll really have to think about that one later on. It's about 1 o'clock in the morning. And I don't know, incredible. Quick side note, but I'm actually kind of glad that this happened in a way, because I ended up just barely drilling all the way through the bolt so that it fell out. But if I had stopped that hole slightly short, it would have been fine until I tried to hang the sword from this chain link, probably later on in the video, and it probably would have broken, and it probably would have landed on me. So I guess, count your blessings? Whew, that could have been incredibly dangerous. Unbelievable. All right, so one final note on the whole cutting the bolt in half thing. I was sitting here wondering, how did I not calculate that out correctly? How did I not think about the fact that I would drill through the bolt? And I realized I actually did consider that. In fact, I actually did plan it out. I planned the whole depth precisely. I planned out the threaded portion of the handle precisely. I made sure that I wasn't going to hit that bolt. But what happened is, all the issues with cutting the handguard in half, I ended up removing quite a bit of extra material in that process, inadvertently, through a large series of screw-ups. And then when I had the welding nightmare, where I had to re-weld it 9 hours straight, basically, I took so many milling passes. They were light passes, but it ended up being quite a bit. And so this material is quite a bit shorter than it was planned out to be, is what I'm trying to say. However, the icing on the cake is I was supposed to drill the hole 1.5 inches exactly. And while I was drilling it, I was like, oh, let's just over drill it a bit to give myself a little bit extra room, right? Because, the drill bit doesn't have a perfectly square end on it. It's rounded over, right? So I wanted a little extra clearance for the handle, so on and so forth, not thinking back months ago when I actually planned out the dimensions of this thing. And long story short, multiple screw-ups leading to a much larger screw-up. So I'm going to deal with this thing later. I'm going to finish up the machining here. There's not much I can do about that bolt for the moment. I'm probably just going to weld it inside the hole. That's probably the best bet. All right, let's get going on tapping this. And then we can do the circular decorations on either side of the hole, and that should pretty much finish up the machining at least. Oh, there's one more detail that makes this bolt cutting incident much more serious than I initially realized. The issue is I was using that bolt to hold together the two halves of the handguard so that when I welded it, it didn't, warp up, the pieces didn't warp away, and well, you can probably guess. Now there's clearance. I don't know if you can really see it. Yeah, there's quite a bit of clearance under there. That end is picked up. So same thing on the bottom. You can see daylight through there. I can't really tell on the viewfinder, but it's not good. That's gonna take another whole plan. the hits keep on coming. I don't know how many mistakes I can make in a row, but I'm definitely setting the world record here. I'm actually not even sure what happened. I'll have to review the footage. What I was trying to do is I was trying to feed the table away from the chuck so that I had clearance for the tap so I could move the table over. And I think I did it the wrong way, so the blade was moving towards the machine. I'm not really sure how I could have done that, but I think I threw the wrong lever when I was trying to fix it. So then the table started going this way and it shattered the tap. It may have broken before then, I'm not even sure, but it all happened in a span of, 1 second, I guess. But we got it trashed, collet. It's all destroyed on the outside there. The tap, well, I guess I don't have to worry about damaging it with that pipe wrench anymore. That's the end of that. I've never seen a tap this big break before. And honestly, I'm shocked that the machine didn't break or something didn't break in the machine, because that had to have been a lot of force. But everything in the machine seems fine, it runs perfectly. I just gotta replace that collet and I gotta get the other half of that tap out there. That is gonna be awful. Can't wait. Look at these threads. Well, the good news is this might be salvageable. You can see right here when the tap kind of twisted to the right, it must have partially torn up some of these threads right here. The rest of them do not look bad. It's just some on the right side. So let's see if I can try to remove these and then run a new tap through it. So I started the camera a little bit late, but a random pro tip: if you ever break a tap off like that, especially one that big, the thing about taps is they're very, very strong, but very, very brittle. So I just used a punch and a big hammer, and I just hit it enough times that it basically shattered the tap into little tiny pieces, and I was able to pull them out. So at least that's one problem down. I just realized in a viewfinder you can see the holes, the vertical hole where the eye bolt went through. I guess that would have been noticeable to me at some point, so it probably wouldn't have been a catastrophic and fatal failure later on. Maybe? Alright, I don't know if the tap handle was in the way of the camera. I just suddenly realized the angle may not work, but I've gotten the tap started. This is the new tap. I think I followed the previous hole. It seems straight in both directions, so I'm just going to continue to hand tap it here. Extremely difficult. I have to use this pipe on the handle here. It's kind of like carving its way through all of the debris in there and the kind of partially torn threads and everything. I'm pretty sure I've already ruined this tap as well. I heard some cracking, so I'm just going to keep going until I can at least clean it up enough to take a look. Alright, we've got a few threads in there. It looks pretty salvageable, I'd say. You can see a little bit of damage right there at the bottom. Doesn't look too bad. You can see the teeth on the tap are broken off at the end here. It's right about there. I'm going to go a few more turns just to make sure I've gotten through the bad stuff, and then I'll swap out the tap just so I don't ruin a third tap. By the way, these taps are like $250 new. That is one expensive hole. That's all I can say. Alright, well, fatality number infinity. I broke the end of this tap wrench off. That's fantastic. Alright, I'm using my biggest adjustable wrench here. I don't know if you can see how big it is. It's a 24-inch. Hopefully this gives me enough torque, and hopefully this tap doesn't break. Alright, this tap's got several chipped teeth. It's getting really hard to turn. I'm afraid I'm going to break it. I think we've gotten enough. I've got like 4 or 5 threads. We're probably over ½ an inch deep now, so I'm going to switch to a better tap, and hopefully I don't break that one too. Much easier. Well, I say that while holding a 2-foot long wrench, so. Okay, well that was uneventful, thankfully. You can see we've got threads all the way to the end there. Looks pretty good. You can see the damage right there. Not awful. We have plenty of thread, plenty of strength. All right, let's handle these two little circles on either side here real quick and then move on from there. So I was just about to finish up for the night after putting these two circles in there, and I realized, I don't know how well you can see that, but they're off. I'm somehow keeping the streak going here. That one is too far to the right, that one is too far to the right. I haven't confirmed this, but what I think happened is, I originally did the math that these two circles would be 1 3/4 from the center hole. So when I had this center hole lined up with the spindle, I zeroed out my display over here, and then, you know, I've been doing all my work based off of that location. I think when the tap broke, it shifted the whole thing over slightly, and I didn't realize it, so I was still thinking, you know, zeroed out on the display was the center of this hole, and it was not. It was probably slightly to the right. And then, so I just counted over 1 3/4, put one here, went back here, 1 3/4, you know, put the other circle, and they're off. So, yeah. Luckily they're nice and shallow. I guess what I'm gonna have to do is I'm gonna have to unclamp this whole thing. I'm gonna have to realign everything perfectly again. I'll re-weld both these circles, skim it off again, and then put new circles in the right location. Should only be like 3 or 4 hours of wasted time. I should be used to it by this point. All right, so it is now almost 2 weeks later. I actually ended up getting really sick with a sinus infection, and after my long train of repeated mistakes, I was kind of burnt out, so it all coincided for a nice little break. But here we are again. We gotta weld up these improperly placed circles. I would like to TIG it, but given on the incredible amount of problems trying to weld on the other parts of this, I'm just gonna MIG it, and then I'll mill it flat again for like the 9th or 10th time, and then I will attempt to correctly place the circles, you know, again. Side note, if you look very carefully, you can see the blue outline, just part of it, of where I had laid out where the circles are supposed to be earlier. Of course I can see it now, but when the blade was over in front of the spindle and I had the cutter sticking out, I couldn't actually see that little blue line that would have told me that I was off. So, whoops. All right, so here we are. We are all done. I didn't bother filming any of it because it's exactly the same procedure. I just welded out the circles. I did it twice actually because there was some minor defects. Milled the whole thing flat and then put the circles back in. The funny thing is I almost screwed it up again the second time. I had basically done the math wrong. I don't know if you can really see this, but there's 2 blue marks. These are the outside of the handle when it's attached, and so I need this gap between the handle and the circle to be the same as this. And I mean, as you can see, it's very close. Same over here. I actually had it off by, I don't know, it was 50 thousandths of an inch, 1.25 millimeters. Not crazy, but you probably would have noticed it. And I definitely would have re-welded this and redone it again. So, yeah, guess I got lucky checking and rechecking this time. All right, so that is one major screw up that I have resolved. Let's work on the one where this thing is lifted up off the surface. I've got a pretty good idea how I'm gonna do this now, since it's literally been weeks and weeks since I screwed it up originally. I had plenty of time to think about it. Let me get this set up and I'll explain what I'm about to do. Look at all the cat hair on this thing. I wonder how that happened. Do you know anything about this? Yeah, Yeah, I didn't think so. All right, pardon the noise, my air compressor is filling up in the next bay, but my idea to get this thing to kind of squash back down is very similar to how it was held in the first place. You know, this part of it anyway. I'm gonna drill a hole all the way through both pieces, and ideally I would just bolt it together so I can kind of, you know, squeeze the whole thing together and then just weld over the top with a plug weld. Grind it all smooth and you'll never see. Problem is, this thickness is not enough. I had used a 1/2 inch bolt before, and here's one of the nuts. You can see it actually does fit. I mean, barely. I could potentially make a hole there, but the problem is, you know, how do you tighten that? Here's the socket for it, and it is actually larger, very slightly larger than the width of this thing. So that is not gonna work without some major hassles. So what I'm gonna do is I'll drill the hole and I will insert a modified bolt. I'm gonna cut down the head of the bolt so it's not so wide, and then I'm gonna squeeze the whole thing together with a press, and I'll weld the bolt in place while it is squeezed together so it'll stay that way. That'll eliminate the need for a nut and the clearance for it and the associated socket. So should work, it's just gonna be trickier. Alright, one final note, as much as I hate to do it, we're going in dry on this one. I can't risk oil contamination of this hole because it's going to screw up my weld, and I'm just done with all that for now. Alright, so I drilled the hole 1/2 inch, and then I drilled an additional recess 5/8 of an inch. So I'll have a shoulder, you can kind of see it down there, a shoulder for a bolt to sit against. This is what I made. It's just a bolt, an Allen head bolt that I turn the head down, and then I cut it to length. So the idea is, it's just under the surface there, and you can just see it. It's just under the surface on the bottom. I cut it a little shorter because, you know, as these plates compress together, it's gonna take up that gap on the bottom. So this is looking pretty good. Now I need to press this together somehow, and I have an idea for that. Okay, well, this took several hours. It actually took 2 nights or so. I ended up, in order to kind of squeeze these together, I had a bunch more clamps than this. I'm just leaving these here for the time being. You can see how tight these are. You see the bend in this clamp. It's on there really, really well. And I use my torch to heat up the whole thing to basically red hot. In fact, I can really feel that. Actually, it's almost painful having my hand that close. I actually wonder how hot this is. It's pretty hot. It has literally been like 10 minutes since I stopped. So yeah, it's up there. I don't know if I actually explained, but this is actually the bolt here. I'm trying not to get my hand too close. That is really hot. It clamped the bolt down into the recess there, and then I welded it from the underside. Can you see that? Yeah, there's the weld right there. You can just see the tack weld at the end. But I think we got it as good as we're gonna get it. Let's see. It looks like there's a gap, but I literally could not move the clamps at all. Yeah, I don't see any daylight through there. I think there's just a slight chamfer on the bottom of the guard piece, and it makes it look like it's off the surface, but let's see the bottom here. Any daylight? I do not see any daylight at all. That's about as flat as it's gonna get. I see a little daylight over there, but that's, the guard ends right there. It's very dark, so the daylight is actually under the sword itself. All right, instead of worrying about the visual here, I figured I'll take a piece of paper. Paper is, 4/1000 of an inch thick or so. And let's see, can we slide it under the guard? Can't really see what I'm doing. Just the tiniest bit, only maybe the last little bit, the corner of the paper, and then it stops. It's really just that outer edge that's lifted up slightly. But I think that's as good as it's gonna get. I don't know what I could have done better. I basically used every clamp that had enough reach to actually get to that location there. A big hydraulic press would have been good, but I don't really have anything like that. And even if I did, trying to get this sword onto it would have been a nightmare. Guess I'll call it good for now. I'll let this thing cool down for like, about a week. And then we'll take these clamps off and see how it goes. All right, so I got all the clamps off, let everything cool down. It didn't really move too much. I don't think I actually moved at all. So my little welded bolt trick seemed to work. I welded the top and bottom, and I'm actually gonna try using this long end mill to just face the top of this off. I've never tried anything like this before. It could be disastrous, so I made sure to use my most expensive cutter. That's brand new, never used it ever, so I guess we'll see how it goes.
Discovered that my cell phone actually has some pretty excellent low light capabilities, so I ended up switching over to that for the shot. I love how trippy this looks. It's almost mesmerizing. And of course, since I had my cell phone out, might as well add some slow-mo action to the shot.
Okay, I machined the top and bottom. I had to touch up the weld on both sides and then remachine it again. It's actually like 2 days later now, but I think I'm pretty happy here. I did find it kind of interesting the way the light plays on the machine parts. You can actually see where the welds were. They're like wrinkly looking. You see up there, I mean, it's perfectly flat. It feels like glass. It just looks wrinkly. You can see how perfect that is. It's kind of funny. Over here it's like a little duller, because I guess the machine must have some more wear in this part of the travel. And then it gets, shiny over here, and then dull again. So it's just, wear in an 81-year-old machine, but it's just interesting how it kind of shows up like that. All right, so last screw up to be fixed here is the chain link that's on the other side of the sword. So let's get this unclamped, let's flip it over, and let's see what we can do there. Alright, so we need to weld this thing back on from the inside. I've got it positioned perfectly, and let's see if this works. Alright, if I shine a nice bright light in here, you can see the remnant of the bolt sticking down through. I'm gonna flood this whole area with that anti-spatter stuff. I'm gonna weld it, maybe. It's actually pretty deep if you look at it from this way. I'm not even sure if I can reach it, but ideally I can weld it. And then I'll run the tap through it again to clean up the threads if any spatter gets in there, because otherwise it's going to require much more severe solutions. Alright, as you can see at the very bottom of that hole, there's like 3 significant tacks on there. At the bottom of the hole there, you can kind of see those BBs. Very hard to get the light and the camera at the same time. Let's see if they're stuck. Doesn't appear to. I think there might be one that's stuck. Let's run that tap through there real quick and see if we can clean that up. Oh yeah, I got this sweet Greenfield tap wrench. This is an old school one. It's probably 3 times heavier than the one I broke, so tool upgrade, yeah, not too bad. It's just a little resistant. I'm not even using any lube because I'm trying not to contaminate that area again in case I need to weld it, but that's it, it just bottomed out. Pretty good. All right, now we are onto the pommel. I am going to be carving it out of this 3-inch square stock here. I was originally going to do the angles with a bandsaw, and by angles I mean these angles here, as you can see from my highly technical blueprint. I've used a bandsaw in the past, it works out pretty well. It's a little bit finicky trying to get all the angles exactly the same, but it's no big deal. However, my bandsaw is in the bay through that door, which is unheated, and it is currently -6 degrees, and I really don't want to deal with it. So in the interest of using this milling machine a little bit more, kind of working out some of the bugs a bit more, getting more familiar with all the changes I've made, I'm just gonna do it here. I figure it'll come out really accurately too, because, for example, I'm making this first cut here. This is, here, flip this around, these are the short cuts at the end. That's pretty much what I'm starting with. And I've got to stop on the end here so that I can just flip it, you know, 3 times after my first cut, and then all the cuts will be exactly the same depth, exactly the same, position and so forth. So we should be very accurate with minimal work. If we spring over here for a second, you can see I've already faced off the end. It's nice and flat. It's perfectly perpendicular to all the sides, just to give me a good starting point. All in all, should be a pretty simple operation. It's just gonna be, once I get the shape of the thing, all these angles done, I can't really show it to you here, but there's a 45-degree chamfer to all the angles as well. Maybe I'll put it up on the screen if I edit this later. I will probably take the stock and put it in a V block so it's angled at 45 degrees, and then just repeat the cuts. Something like that, but stay tuned. We'll see how it goes.
So I happened to catch this during filming, but this is how I usually do things. I keep a large variety of source material images on my phone, so while I'm working, I can check and recheck if something looks correct.
Here she is, fresh off the milling machine, burrs and all. You see the surface finish is not that great, but I wasn't shooting for a good surface finish. Still, I've seen worse, especially considering this is mild steel. It tends to be pretty gummy and leave a kind of nasty surface finish. But yeah, I'm pretty happy with this. I'd say it looks pretty good. We've got everything we need. All the bevels are done. Everything kind of lines up just about right.
Okay, so there's sort of a jump cut here due to a lack of filming, but I ended up just cutting the pommel off of the larger piece of stock, milling the cut end flat, and now I am drilling it so it can be threaded to attach to the handle itself.
Alright, so one of the handiest things about tapping on a milling machine is this little tool right here. This is a spring-loaded tap follower. It's actually pretty tough, but it's designed to go into the center hole on the back of any tap. So you can just kind of do this, and then you can press down. The spring is keeping tension, and now you can, manually turn the tap, and it will go in perfectly straight. Normally I would power tap, but this is a big tap. It's just a lot of torque, and I'd rather just do it by hand, I suppose. No real reason for it. The machine can probably do it. I've just never tried it. I'm only tapping, you know, one hole here, so who cares how long it takes. Probably help if I put the tap wrench on first. All right, final step here is just a little countersink and we're good to go. All right, that's it. Nice, clean, tapped hole. This thing is actually done, other than just hand sanding it to give it the final finished look. Let's go get on that right now, in fact. Alright, that's about it for this pommel here. I would say we're done. Sanded it out to 120 grit. It's probably as far as I'll go. It's slightly rough, but clearly the Dragonslayer is not some polished piece of fine art, so I'm calling this good. It's pretty consistent finish. Everything kind of lines up pretty well. I intentionally softened up all these lines and bevels just to kind of make it so it doesn't look quite so machined. I mean, it's still pretty straight and nearly perfect, but you know, Godot didn't have access to a milling machine, so it needs to look somewhat natural. And besides the fact that I basically screwed everything up numerous times, like introduced enough imperfections that I would say we're looking pretty good here. This is a hefty chunk, by the way. This is a solid 6 pounds, almost on the dot. And I did make this removable so that you can unscrew it and throw it at your opponent to end them rightly, of course. Tiny side note here, but this actually took me 3 days worth of hand sanding to get it to look like this. The problem is, when you're sanding, say one of these little bevels, if you put a little too much pressure, say on the left side, like right here, this line moves outwards, and then it doesn't match up with this line on this side of the bevel. And then so you gotta sand this one a little bit, but now they're both, you know, a little bit off. Like this part is wider than it is down there, so you gotta sand it down there a little bit more, sand it down here a little bit more, on and on and on. And then finally, when you get everything perfectly matched up, it looks like, you know, it's pretty good like it is now, but then you realize that this line is off, so then you have to do more sanding, and then, you know, on and on and on. I would spend an hour on it, I'd come back to it later, I'd see a new flaw, I'd sand that out, you know, try it later, and on and on and on and on and on. But I think I've got everything that looks pretty solid, I would say. It's a little wavy here and there, but honestly, I'm a rabid perfectionist, and at this point, I know I'm done because I'm slowly making the piece worse. And I figure once I'm making it worse, I have reached the limit of my capabilities, and we are officially done. So, all done. Okay, we are on to the handle. I'm going to be making it out of this pretty significant chunk of steel here. Now, most of the handles I've made for Dragonslayers in the past have been much smaller. I would say right around 1.25 inches. This is 2 inches. The reason I made it smaller in the past is because 2 inches is pretty substantial for an average human to hold, and my previous versions were meant to be held by humans. They could be swung by an average, strong person. In this case, nobody can pick this thing up, so I'm more interested in making the handle perfectly accurate. As far as I can tell, the handle is supposed to be as thick as the blade, so this is exactly the same size as the blade, 2 inches. Alright, so this handle is actually not going to get welded on. This is actually going to be my first non-welded handle. I'm simply going to thread both ends of it. So the pommel will go in one end, and then the handle will screw into the sword itself. In this case, the blade is so thick that I have enough material that I could actually drill and tap a, you know, large enough thread size that this would still be plenty strong enough. Normally the blades are thin, and they're also very hard, so it would be difficult to, you know, drill it and tap it. It'll probably destroy the tap in the process, so, and the drill for that matter. So I'm really trying to avoid that. And just for reference, the end that's going to be inserted into the blade is going to be a 1-inch diameter. And according to the engineering charts I looked up, even in the softest material possible, a 1-inch, you know, stub has a shear strength of about 20,000 pounds. So even if this sword were usable, it would still be more than strong enough. All right, enough chit chat. Let's go throw this thing in the lathe. I think I'm gonna do the threaded ends first, because if I screw that up, then I have to scrap the whole thing anyway. So let's get to it. Jesus Christ. Yeah, I think it's probably, I don't know, 15 pounds or so, just by itself. So I just noticed this, but check this out. This end has clearly been cut off by a bandsaw. It's, you know, it's pretty reasonable, round-ish, I suppose. Now if we check the other end, it's like, I don't know. I thought maybe it had been dropped a bunch of times, but I think this is actually the end of the piece, you know, as it came from the factory. You can see it doesn't have any cut marks on it. It's just like all mangled up and not even remotely round. But luckily, I'm gonna have to remove a bunch of material from the OD of this. All right, so I turned the camera off because this was kind of frustrating to actually check this up. I actually need that end chucked and that side, but it's so messed up that I have to do it this way. It took a little bit to get this reasonably true. The whole thing is just kind of like off in different dimensions at different points, but I've got it somewhere in the middle except for that end, and I'll demonstrate right here. Not too bad until you get to that part, so yeah. Alright, so I'm just going to skim the whole thing, make this true. I'm going to do a little bit of work on this end to do the threads, and then I'm actually going to flip it to do the taper.
So it may not be immediately obvious what's happening here, but I'm actually using a die inside the black die holder hanging out of the tailstock on the right side of the lathe. I'm turning the handle manually by rotating the chuck on the left side. This allows me to thread the end of the handle straight so that the pommel will line up perfectly when it is screwed on. At the very end here, I swap on a regular die handle so I can finish the threading. And then of course, it's time to actually test it out. And then I've got to flip the handle around in the lathe so that I can machine and thread the other end of it.
Alright, so we have gotten this thing pretty round. I've done most of the machining on the ends where it's going to be threaded into the pommel and into the sword itself. So the only thing left to do is to taper this. Now this was a very tricky part of the sword, I guess like most anime swords. The handle appears different in almost every frame of the manga. Basically it always appears tapered to some degree, but to what degree and where the taper is kind of variable. Basically this is going to be the big end, so I've kind of got this roughly sectioned up. What I'm going to do is it's going to start big and it's going to get gradually smaller until this point, and then it's going to stay that consistent size till the end. That seems to be the way it is portrayed most often. Sometimes the taper is shorter, sometimes it's longer, sometimes it actually tapers down and it gets slightly bigger right at the end, right where the pommel is, just the last little bit. But basically I can't even tell if the handle that gets larger down here or if there's just a few more wraps around the handle of that, you know, white cotton bandage or whatever Guts uses, and it's kind of just making it look a little bit bigger. It's extremely inconsistent, but I think this is sort of the most common way it looks, and or, you know, sort of a combination of all of the different styles it appears in. Taper isn't going to be very big anyway. I mean, like this half of it is only going to be a 1/4 inch smaller than the thickest part down here, so it's not huge. If it doesn't look right, I'll take more material off, but this will at least be a starting point. Well, I pulled the back of the machine off and everything was blazingly hot. This is the speed controller. I couldn't even touch it. There's all kinds of melted components. You can see this with stuff in here. Actually, this thing was in there. It melted out. Some of the wires melted together. There's, you know, exposed wiring from the wires melting together. A couple places. The motor was incredibly hot too. I'm guessing, I don't know, either the speed controller or the motor itself burned up. Hard to really say, but pretty amazing. I spent, I don't know, $3,000 or $4,000 on the machine, and I've used it maybe 20 times. So slightly disappointing, but that's what you get for buying Chinese junk, I guess. Good thing I've got most of this done. I guess I'll just do it by hand, the rest of it. You know what? On the bright side, at least I have a nice hammer now. This thing actually would work extremely well as a destructive device. It's honestly too heavy as it is. It's like weight at 13 pounds is way more than you would actually use for a hammer. Even a sledgehammer isn't that heavy. Usually they're like, I don't know, 9 pounds or something like that. But man, whew, you really do some damage with this. So random side note, but I threaded this end for the pommel. This is 3/4 inch, but I did the other end 1 inch. There's no real reason for that. I should have just used the same size. I mean, 3/4 inch is more than strong enough, even for a sword this heavy. Not that anybody can lift it or wield it in the first place, but, you know, anyway. The only real reason I made this 1 inch is because I have this huge 1 inch die that I've never used, and I just kind of wanted to try it. The only downside is you can see how huge this is. Now, like, this is the 3/4 inch die. You know, the entire body of the thing is massive, and I don't even have a die holder that can hold this thing, so that's why I haven't threaded the end of that yet. But I was thinking, I made that exactly 1 inch. Now I've got 2 milling machines that can take 1 inch tools. Well, how stupid would that be? Come on. You can do it. Oh, oh. I mean, you know. Okay. Well, I mean, that's about it. If you squint really hard, it looks like a lathe. Now, I could have actually mounted a lathe cutting tool to the table and had it like pointing up and almost use this machine like a lathe. The problem is the set screw down here that's holding on to that little stub shaft. You know, the shaft doesn't have a flat on it, so I feel like with the force of trying to actually lathe this thing, it would cause the workpiece to spin in that holder. So I'm just going to use an angle grinder. I'll take a step back here. I got this whole network of welding blankets set up so that it'll catch the sparks. The sparks being, you know, fine metal shavings and abrasive grit, and I don't want to get it on all of my other machine tools, so hopefully this works out okay. I'm going to just stand here on this side, that way I can still reach the control right here. I can turn it on and off, and I can even kind of stand to the side, so, you know, should this thing rotate out of here, and it'll hopefully not kill me. I was initially going to use this machine over here with the vertical spindle and hanging it straight down, but I figured if something happened, it would, you know, spin in a 360-degree arc and it could hit me, and I mean, you would definitely die from something like that, so that was out. All right, I just want to say, I know this isn't nearly dangerous enough, but I am definitely channeling my inner Michael Cthulhu today. Thanks, Mike, for the inspiration. Side note here, the scratch patterns from the different amounts of pressure I put on this piece make it look very trippy and very difficult to see, you know, how the taper is doing. I think we're pretty close. Alright, I think it's about good enough. It's pretty rough, as you can see, but I want to leave it rough. A rough surface will allow for a better adhesion when I do the wrap, so this is fine. Not sure if you can see the taper. It's fairly subtle, but I guess that's kind of the point. You can really feel it when you're... Yow! No, let's not do that.
A few moments later.
You can really feel it in your hand more than anything. It's significantly smaller down here. You can really feel it, yeah. That's funny. I don't see it on the camera, but trust me, there's a taper there. I nicked the end of this tool holder quite a bit, but it should be fine. Really glad I put down these welding blankets here. You can see how much of this this grit came out everywhere. There's pockets of it all over the machine, so it was definitely a good idea. A brace of grit in the workings of a precision milling machine is not the best idea, so I'll have to clean this up very carefully. But we should be good to go for now. I just gotta wait for the die holder so I can do that end, and the handle will be done. Amazing. Alright, so we've got the handle basically done, except we need to thread this end. Normally this would be done on a lathe, it would be nice and easy, but as you can see over there, my lathe is still in pieces, so that's not going to happen anytime soon. Now, it is important to get the threads on this perfectly straight, because this is the end that threads into the blade itself. So if the threads aren't straight, the handle will be crooked and it's going to be a huge problem. Having said that, I think I found a pretty good way to get pretty straight threads on this. I'm going to take this and I'm actually going to put this in a 1-inch tool holder, similar to how I kind of did the taper originally. And it's a nice tight fit. The idea is I'll clamp that down, then I will clamp it in this vise so that I know that it's perfectly in line with the spindle and this tool holder, like so. I've got my digital readout zeroed out here just to make sure I can return back to this position. Now I'm gonna lower the table so I can drop this out of the tool holder, and I'm gonna replace it with that bolt, which has the same exact size threads that I need on the end of this handle, like this. Then I'm gonna thread this die on this bolt.
I think I accidentally stopped recording right there, but I ended up returning the machine's table to the zeroed position to ensure that the bolt and handle were perfectly aligned with each other again. Then all I have to do is turn the die just like this, so it transfers from the bolt to the handle nicely.
What the hell? You gotta be kidding me. Well, I'm definitely setting a new record for how many tools I can break in one build. That was a brand new, I think it was a $190 die. I have no idea what happened. Looks like I made about 2 threads, but look at this. Like one of the threads is damaged. How did that even happen? I don't understand. That is stuck on there. One of the teeth broke. I mean, the teeth look good. I don't see any real damage to them. Actually, I don't know if you can really see it. On the right side, there's some chipped teeth. That is incredible. Time to wait another month for one of these things to come in.
Okay, so while editing this video, I was able to see what happened. Right here, the handle spins slightly in the vise and I don't notice it. This means that the die is now out of sync between the two pieces, causing it to bind up and then break shortly afterwards.
Alright, so we are in the storage bay of the shop out here. This is my uninsulated, unheated bay that, you know, I store everything in, as you might imagine. I noticed this the other day, and I'm not sure how well this is going to show up. I'm going to try, but it's possibly the largest spiderweb I've ever seen. I can see it here in person. I don't know if you can see it on the camera, but basically it extends from the entire edge of this table outwards, and it goes all the way to the edge of that tray. I don't know if it's more visible from this angle or not. I can actually see it on the viewfinder a little bit now. It's pretty good size, but then it goes up all the way. You can actually see it there. It goes all the way 20 feet away, up there to another huge spider web. And if you look closely, I don't know if you can really see, it looks like they caught a bunch of bugs. But those are in fact thousands and thousands of baby spiders. So I don't know where the mama is, but I'm guessing she's a pretty good sized spider. Look at that. Yeah, now I can actually really see it on the viewfinder. I think the black windshield really kind of shows it a little bit better. I wonder where she's hiding. Not under here. I don't see anything. Must be hiding way up there somewhere. Okay, it's a few days later. I've got a new die in here. We got a made in the USA one this time. I've never actually used this brand, but hopefully we've got enough meat on there. I mean, that's 2 full threads. That'll give us a nice start. It should stay nice and straight. I just hope I don't end up with one of these situations again. Alright, well, that was completely uneventful, I suppose. Okay, well, I mean, we're threaded. I guess you know what comes next. Oh, it doesn't thread in all the way. Alright, so I ended up shortening the threaded portion because the weld repair inside that hole has shortened the depth of the hole, so nothing fit together anyway. So those damaged threads from the broken die actually have no effect at this point, thankfully. So it's a little wobbly because I haven't actually tightened anything. I just kind of wanted to see how it looks real quick. And I would say it's not bad. It's actually really hard to tell because of the way the handle tapers down. It's hard to tell what I'm looking at, but I think we're pretty close. Anything left can probably be, you know, manually bent out. All right, good enough for now. Let's get this back apart and let's work on the infinite sanding and filing of all these little bits of leftover material from the milling here. Should take quite some time. Okay, so I got the sword in my welding / grinding bay now with the better lights, and I have terrible news. I was completely wrong about the handle being straight. It's off in 2 different dimensions, if you can believe that. It's fairly obvious when you look at it here. You know, we're fairly tight, but then you can see there's a small gap here, and especially on the left side. So basically the handle is down and to the right very slightly. And I guess you can see it. Yeah, I can see it now that I actually really look at it. It all depends on your perspective, but did some measuring, and as far as I can tell, it's about 3/4 of a degree off in both axes. You get the idea. So now, what's the fix? I think the fix is pretty basic here. We're gonna go the caveman route, and we're gonna use that big piece of pipe on the end of this for some mechanical advantage, and then we'll take some assistance from our blue friend right here to help persuade things along nicely. Given that it's such a small defect, I think we can bend it out easily. Ideally, I'd probably just cut those threads off, remachine the end of this, make the handle like 1 inch shorter, and then recut the thread straight. But my lathe is broken, and I have absolutely no idea when the replacement motor is coming in. And I have to get this whole sword done and delivered in less than 3 weeks. So I'm just gonna have to go with what I have at the moment. Wow, so that was it. It was actually no work at all. I didn't even need to use the torch. It just cold bended a little bit and got me exactly where we needed. You can see these gaps look pretty identical. I haven't actually tightened it all the way down because I want to remove this. All right, let's see how this checks out. Since I milled the top of the guard flat, it should be, you know, as flat with the blade as possible. So zero that out. Okay, now the end of the handle is straight, so this should give us an accurate reading. So, I mean, whew, not bad for my first try. Let's try the other way. Yep, well, I mean, I don't know, that's just gotta be luck. There's no way. I literally bent it for like 10 seconds and it ended up perfect. Now to measure the side to side, I'm going to use my very nice digital caliper here. Let me set the camera up on a tripod. Okay, so if I kind of jam the caliper in this corner, let's see, what do we get for distance? Got 13.126 inches. Now let's try the other side. Got 13.134 inches. That's 0.08 of an inch off. That's 0.2 millimeters, maybe 2 human hairs side by side. I mean, it's not gonna get any better than that. If I try to adjust it, it's gonna be worse. So, calling it good. we are looking pretty good here. I'm more than halfway done. I've got pretty much the whole guard section, you know, sanded and filed down. You can see down here there's still some defects to take out where, you know, the milling wasn't just perfect. I'll have to flip the sword to do that. I've got the rest of it cleaned up. We're looking really nice. The only thing left to do on this side is this part of the guard. You can see how it got all sort of blackened and nasty from all that heat. The only problem here is it's going to be difficult to sand this section without getting into the black oxide here and ruining it. So what I came up with is this. This is actually a piece of vinyl. I cut it on my vinyl cutter, and I'll just remove the circular section and I'll use this part as a perfect template for this. I can lay it down and it'll, you know, kind of half-assed protect the sword while I sand the rest of this. It shouldn't take much. I already kind of finished it. It's just, it's got this like blackened oil and maybe even a little bit of scale on it, but shouldn't take too much work. And we can flip this thing over and clean up the other side, and we're done. Alright, now last thing to do here is to thread the handle in. I've cleaned up both sides of the mating surfaces and we're ready to thread this handle in. Now I'm going to use Loctite, which is a thread locking compound. Oddly enough, the red compound comes in a blue bottle, and I don't know if you can read that, but the blue compound comes in a red bottle. It's kind of ridiculous, but the red is kind of semi-permanent. You have to use heat to remove it. I'm going to use it on this side, and then on the pommel side I'll use the blue, which is pretty strong, but it can be removed without heat. Alright, so the handle is threaded to the sword, the pommel is threaded to the handle. Now trying to get this flat surface parallel to the guard or the blade is obviously a slight problem here, right? Normally I would just position it, fixture it, and weld it in place. In this case, I'm just gonna stick this guy on here, and I'm gonna zero it out. Let's just make sure here. 0, 0. No way. Ah! That is pretty amazing. That was like a 1 in a million shot. Well, it looks good to me. Just a little sanity check. The Loctite will keep it in position, so it'll stay that way. We're looking really good here. I'm just going to throw a quick wrap of some white cotton bandages on here, and just to see what it looks like. Alright, well, that is all she wrote. I would call this done. I'm gonna give it a final polish and waxing and such right before I pack it up, but this is 99.9% of the way there. I think it came out pretty well. I can of course see some random defects, but they're always going to be there. Truth be told, I have never actually been happy with any of the swords I've made, but that's just the way it goes when you're a perfectionist trying to make perfect creations. Alright, so it is time to lift the sword. Now I have made this sort of improvised platform here so I can pick it up. I needed to raise the sword so that it doesn't chop my feet off when I drop it. My feet are gonna go in these cutouts right here. And I'm wearing armored boots, but as you can see, it fits under here. It gives me just enough clearance so that, you know, I'll keep my feet. I've got to rig something up so that I can actually grab the sword, because grabbing it by the edge is not gonna happen. But before I do that, I figured I might as well weigh it. Now, I've got the scale zeroed out. It actually says -16, and that's because it is zeroed out holding this thing, but it is currently slack. So we are ready to go here. I'm gonna pick this thing up, see what she weighs. All right, I had to wait a minute for the sword to stop swaying a little bit because the weight was jumping all over the place, but it looks like we are at 147 kilograms. We have air under the whole sword here. It should be good to go. I think 147 kilograms, just doing the math in my head, I think that's actually right what I guessed it to be, 325 pounds. That's gotta be really close. Let me go do the math real quick. Well, that's it, 324.08. I was less than a pound off. That is, I don't know what to say about that. That's pretty crazy. All right, let's put this thing down. Let's get it in position. I'll strap some handles to it and let's see if I can pick it up. All right, here goes nothing. Gonna use my old man lifting belt here. Not that I necessarily think I need it, but I really like how it gives me this nice muffin top and muffin bottom at the same time. Also gonna use these quasi straps. Again, not that I think I need it for this weight, but I got blisters all over my fingers and I really don't want to drop the sword. It would be a bad day. Yep, that's pretty heavy. I can't move my legs any further because the ratchet strap is digging in. Woo! Just passed out there. Whew. Already even just holding this stupid thing up. You know, I knew how tall it was, but I guess it didn't really register until I actually stood it up next to me. I'm like 6'3" or so. That thing's right about 6'8", I believe. Almost 80 inches. Alright, that's it. We're finally done. Believe it or not, that was 397 days of work. I couldn't tell you how many hours it was, several hundred. I didn't keep track. I do have a Patreon if you would like to support me and enable me to create even more ridiculous things in the future. Oh yeah, one last thing. Leave me a comment below on which sword you'd like to see next. Till next time.